guys can confirm if you can hear me, and you should also be able to see the screen that I have shared. Looks like some of you are attending the first time, so everybody welcome on board. Next question, can you see the screen? Just one. So yes, voice is not clear. Let me fix it. What about the voice now? Is it clear? Yeah. Voice not clear. Let me fix it. Okay. Give it a couple of minutes. If it's still not clear, probably I'll come back and try to fix it. Looks like voice is coming from very long. Okay. That's a very good voice. Let's see if I can fix it. I'll give you one more. I will log off and log in again. Right? Just do that. I log off and log in again in a moment. Record the video. This is a free session, so the video recording will happen from our admin department. They will upload it to YouTube. You can watch it later also. Let me log back in. I'm leaving now and I'm going to come back in a moment. How is the volume now? Voice? Is it okay now?
Please post yes if it is. Fantastic. So we are back into business. Now, before we start, let me give you some context or the situation, what we are at this point of time. This is the second session and also the last session of your GitHub workshop. It started last week, but we could not finish everything. So it's extending for this weekend, which means some of you might have missed the last week's session. So this whole thing that you are looking on the screen was discussed during last week. I will quickly try to go through that thing just to help out for those people who have missed it. But this is a second session. So we talked about what is Git. We tried to understand that using a very interesting love message analogy. Then we talked about how Git does it, who created Git, and we talked here about what Git cannot do, then things related to Git and GitHub, everything. Then we install Git on a Windows system. And then we looked at the most common Git commands, and we tried to understand the meaning of each of those Git commands on our Windows system, on the local laptop that you're looking at. Then we also looked at some of the very common Linux related commands, but which are used on Git Bash on Windows. Then the most important thing, we tried to understand the architecture of Git. I'll come back to that in a moment. All right. It's fading, right? Just light off, just better now. Should. Yeah, I'm coming there, guys. Just a minute. So can we track part 1 from YouTube? Let me answer that question. Let me track it for you. Salman, just I will give you that video so that you guys can quickly go through it. Even after this session, it's still okay. Yeah, I think this is the one. Is it okay now? So I'm trying to give you that. Yeah, this is the YouTube link, guys. Salman and those who missed last week's session, you can go through it, maybe at a later point of time. All right. So you got that link, right? Let me answer the others questions also. Voice not audible. Ajad, I hope it's audible now. Madhava, can you please elaborate a bit more on what is Git used for so that we can understand? Yeah, give me a moment so we will understand. I'll give you a quick briefing of what Git is. Then, yeah, I think we've answered today's questions. Let me go back and try to give you a quick overview of what Git is. Then we will go into the today's session. All right. Now Git, because we are trying to do it quickly instead of an elaborate introduction, let me try to give you from the context of notes. I will try to add all these things as a notes thing and then post it to the YouTube channel itself as a message or a text attachment. Anusha. So that will happen after this session is done. But yeah, several people have asked for notes. I'll give you that notes also. Now let me come back and give you a context of Git. The first thing, please understand that Git and GitHub, they are not same. So first point, please share everything via Google Drive. Sure, Manu, we will do that. And I'll send out a link to everybody. Now, point number one, understand that Git and GitHub are not same. The difference between these two, we will understand today. And usually it's Git and GitHub. They are used together. So first we will understand what is Git. Then we will see what is GitHub. And finally, we will see how they are used together. Now, coming back to a quick introduction to Git. Let's say you are writing a Java code. I'm going a little fast here because this was covered very elaborately during the last session. Advjava GitLab is also similar to GitHub. GitLab is another company similar to GitHub. So once you understand GitHub, you will have the same understanding of GitLab also. There are just two companies like Apple TV or Apple Mobile and your Samsung Mobile. So once you understand how a general smartphone works, it's easy to understand everything. So if you understand about GitHub, which we are going to do today, you will also understand GitLab. Now, let me answer this what is Git question. So let's say you are writing your code. All right, this is what we have discussed. What happens is when you write your code, you start with some version or something. If you are a Java developer, you would usually start with an Eclipse. So let me launch Eclipse. This is an Eclipse IDE. Most of you are familiar with. Even if you are not a Java developer, if you are a Python developer, you would be using something called PyCharm. And if you are a .NET developer, you would be using Visual Studio. So anytime you write some code using any IDE, your final code is not ready when you try it during your first time itself. Then what you normally do is you change that code and then you come up with a modified code. That is usually called the next version. Let's call it version 2. Then let's say you found some bugs or your team lead found some bugs. So you fix those bugs. That is version 3. Then you modify it again. Let's say you call it version 4. So what is happening here is whenever you write code, there are a lot of changes to the code. The code gets written step by step. It's not a one-time process. Now, when you write such code and you want to go back sometime, let's say you written version 5. I'm still waiting for the Eclipse to come up. Let's wait. Let's see if it has come up. Yeah, Eclipse is up here. So some of you might be familiar because we are talking Java. If you are not familiar with Java, that's still fine. I'm just going to talk about a print statement here. So system.out.println. Let's say your version 1, you thought, okay, hello world is good. And you saved this in welcome class.java. You can see it here in this hello world at the left side bottom here. Where do we have this welcome class.java? It's usually under source. It's okay if you're not familiar with Java. Don't worry. For those who are familiar with Java, this is welcome class.java, which is visible here. All right. This is the welcome class.java. So let's say you written your first Java code. And in your first Java code, which you are calling version 1, you thought the println should be hello world. Then you said, okay, hello world is something very common. Everybody is using hello world. So you thought you will use hello world 1. That is version 2. Then somebody else came in and said, okay, hello world 1 is also not really that good. Go ahead and use hello world 3. So now you have 3 versions. Let's say after 1 month, you visited the same code or somebody asked you, what was the first thing that we have written? That's what looked better than the hello world 2. The client said, okay, let's not use hello world 2. We should use whatever we are using initial. Because you write so much code, it's not possible to remember all the changes that you do. Now, to make those changes or to remember those changes, a new system was called a version control system. I'm going a little fast here, guys. All right, I cannot spend as much time as we did last time. Sorry about that. You have the video, so please do go through that to get a complete understanding, but I'm giving a quick version of what Git is. So what we have here is we make a lot of changes, and each time we change, we want to track it. And that is what a version control system is. Version control system. So every time you change something, that's a new version. Just like we have seen the Java code. You change this to this. So obviously, you're going to remove the first one. So this is your new .java file. Let's say this is version 1. Then you changed it to version 2. This is your new Java file. Your file name is not changing. Remember that. That's one way to store everything. You can say welcome class 1.java, 2.java, but that's not what you want. You want the file name always same. You can't change it. That's your code. But the contents of the file are changing. But you still want to track the change, isn't it? That's when you need a software or a system. And such systems are called version control systems. Now, one of such systems developed by Linus Torvald, he is also the developer of Linux systems, is Git. This is an interesting question. Somebody asked me, is there an abbreviation for Git? No, there is no abbreviation for Git. Somebody said global tracking information tracker or something. There is no such thing. Git has no abbreviation. Git is basically an English word, which basically you can say an unpleasant person. Git meaning you can do Git. It basically says an unpleasant, incontemptible person. That's what Git is. And we say that mean old Git kind of, old person or the unpleasant old guy. If you are in India, probably Buddha Khusat, that's what we normally say. In Hindi, Moslodo antam, if you are in Telugu. So that's what a Git meaning is, the Buddha Khusat. So other than that, there is no specific meaning for Git. So what we have here is a system to track the changes. That's what we are trying to do here. So we are trying to learn how to use Git to make changes and how to track changes that you are doing in your source code. Be it Java, be it Python, be it .NET. Even if you are writing a simple English text, it can still track the changes without changing the file name. This is what Git can do. So in summary, Git is a version control system for text. Now that we said text only, this is the next thing. Can Git track changes to your Word document? No, it cannot. It cannot track changes to your Excel file also. It cannot track changes to your images. This is a very important point for you to realize. Git can only track text only. It cannot track other types of files. All right. So it can track So here in this case, it can track text. It cannot track Word documents. It cannot track changes to the Excel. It cannot track changes to the image file. Means if you change an image file using your Photoshop and save it using same name, Git cannot know it. Right. So Salman, yes, Git is similar to SVN. Correct. That's correct. If you are familiar with SVN, Git is exactly same. If you are not familiar with SVN, don't worry. You can learn it now. It's a version control system. SVNs and VCS are same. So it cannot track anything compiled. This is also a very important point here. If you compile a .java file and turn it into a .class file, Git cannot do anything. It can only track .java file only. Because .java is text, whereas .class is not text. It's a compile code, bytecode. All right. So what we normally every time do is, if you are storing something, if you are using Git, we are only talking about text files. And the simplest way to remember is, look at this file. The file name is welcome class.java. Let's say you make a change every day to this text file. Remember, this all is text, Java text. Every day you are making a change here, but you are not changing the file name. Then you ask Git to track all the changes that you are doing to this file. And to do that, we learn certain commands. So here we are. We've installed Git. And after the installation of Git installation is very simple. Download Git for Windows. That's what you say. It will take you to the Git SCM website. This is the official website of Git. All right. If you open it, you have a Windows client. You click it and it will download it. This one, 64-bit for Git Windows setup. Click it. So this is what gets downloaded. I've already downloaded it, so I'm canceling it. For those who missed last time. So this is the Git exe file that you have downloaded. And when you double click it, it opens a regular Git setup thing. You go ahead and install using default values. After you install it, I'm exiting now. I'm not installing it again. It's already installed on my system. So exit. After you have installed it, you're going to get a command line interface called git bash. This is what you are seeing here. This is how it looks like on your Windows system. This is the application or the command line interface to interact with Git. There is also a GUI version. We're going to see that GUI version after we are done with the basic git bash. So launch this git bash. Let's go ahead and launch git bash. Git bash. Click it. There is some error here. I'm going to close. Okay. So this is your git bash thing. All right. This is how a git bash command prompt looks like. Similar to Linux terminal. Now the commands that we have learned related to Git are these things. Git init is to initiate a directory. So we are usually working with directories here. We have selected one such directory. Where do we have those directories? This is Git repos. No, not this one. I think we have set up a Git repo last time. Yeah. So this is where we have set up a Git repo. Now, the way we call it is, some people call it Git, some people call it JIT. The actual word is Git, Ga. For all who are in Indian, all our languages, be it Hindi, Telugu, Tamil, anything, we have a word Ga. So that is what it is, Git, not Za, not a Zit. All right, it's always Git. This class is how many days? Anu, this is the last session. This is a workshop. So last week we had the first part of this workshop. This is the last and final part of this workshop. But we will have similar workshops in future also. You can attend that if you want. What is Tortoise Git and how to use it? Tortoise Git is one of the several Git products available, like an Android mobile. Android mobile, Ajad, Android is an operating system which can be used by Samsung, can be used by Apple. The same Android operating system can be used by any other mobile provider, right? Redmi, Xiaomi, anybody. So the same way, Git is a product and anybody can use Git. Tortoise is one such company which created their own Git product by taking the open source Git. For those who missed the online session, just give me a moment. Let me post that URL again. Git last week links, link. Can you show the Tortoise Git? Ajad, we will go into Tortoise Git at a later point of time once we are done it. Those who missed the YouTube session, this is the YouTube link. Let's have it. Now coming back, anybody who reinstall Git, so can I use last local repo for new installation? Yes, Git is a tool which can be used with the existing repo. So here, let's go to the location where we have set up this Git repo last time. This is where we have set up our Git repo here. My new get repo one. So I'm going to go to this location, the temp remove cd Here, if you see, it's /c and /d. That's how the git bash works. So here /d temp remo ls list, and this is the git repo that we have worked last week. cd change directory. Cd means that directory name. Now, those who missed last week's session, don't worry too much. These are very basic commands. If you go through that video, you will understand it. So cd, now list again, only 3 commands I'm using. These are 3 Linux commands, which can be used on Git also. So let me refer to the 3 commands that I'm talking about. I'll give this whole thing into your notes, guys. Don't worry. So these are the 3 commands that we are talking. cd, pwd, ls. So cd means change the directory. The description is already here. So we change to /d. /d means d colon. The same way /c is c colon. Slash is this thing, /. pwd is present working directory, which tells me currently where you are working on this screen here. And the last thing I've used is ls-a list all files. All right. So here, let's go back to our git bash ls-a. These are the 3 files that we have created. Some of them are folders. And the most important directory here is .git. This is the directory which starts with a dot. Therefore, it's usually not visible on folder structure. See this thing here. If this is the directory we are talking, let me put it into 2 windows here. So on the left side, this is the directory where you are putting your code. So double click it. So this is the directory we are talking about. And on the right side, you're working in the same directory. If you do a pwd, what's the directory structure here? /d. You can see the directory structure here. D colon temp remo my new git repo 1. This is the one. We looked at it during last time's installation very clearly. Prathamesh, yeah, no problem. If you have reinstalled Git, that should not be a problem. All that you have to do is go to that location wherever your old Git is. And if you have the .git directory in it, your new installation will still work. All right. So here coming back. So because we have .git, everything that Git is doing will be available in the .git directory. All right. So there is a question here. That's a very good question from Prathamesh. What he says is, if I reinstall Git, will it work with my existing directory? This was a directory which was converted into a Git repository last week. All right. How do we convert a regular repository into a Git tracking system? What's the command? So you go into that directory and you execute one of the commands that we discussed last time. Anybody can recollect what's the command is? One of the 5 commands that we talked. The first command, git init. So when you type git init, you are basically initializing a repository. You are telling Git to track everything that is changing in this directory. So what you did last week is you cd'd into this directory, this path, and you executed the command git init. And when you executed this git init command, a Git tool or the Git software created this .git folder. And what's the purpose of this .git folder? Everything that you are changing. For example, if you change something in this file, that change will be stored here. All right. .git. So if you open .git, it has all the internal files and directories related to Git. Now, some of these files are binary in nature. Some of them are text in nature. So when you execute a command, for example, let's say here, pwd, you are in a Git directory, ls-a, sorry, don't use ls-la, ls-a. So here, because you have a .git directory, it means this whole thing is being tracked by Git software. And if you can do a Git status, it will tell you the current status of this directory. We talked about what a branch is during the last week and what is a master branch. And then we talked about how Git knows about these newly added files. So here, this is the directory structure of Git. Inside this Git directory, .git directory, you see this thing, and this thing. Inside this directory structure, the logical structure is these three trees. This is the most important thing that you have to understand. Salman, how to change master branch to dev or QA through git bash command? We will come there. That's called a git checkout. Salman, we'll come to that point in a moment. So what we are seeing here is the structure or the architecture of Git. Especially, there are three areas: working area, staging or index area, and then local repository. Now, these are logical in nature. They are not directories. Remember that thing. Very important. Where these three logical areas are present? Inside the .git directory. All right. So what is happening is, work area is where you are working. So let's say if I create, this is your directory, right? What's the name of this directory? My new get repo one. This is the directory where you are putting all your files. It could be a text file. It could be a Java file. It could be any other thing that you want to try. And inside this, remember this path, d:\temp remove my new git repo one. That's the direction. Now, these three logical things that I am talking are not folders, which means you're not going to see folder names here. Where are these three logical things? They are inside this .git directory somewhere. What Git does is, let's say when you are working in the directory, you created a new file, like we did here. We created a new file. When you create a new file, Git observes that you have added something to working area. So let me create a new file here, right click. I'm just creating a new file, just regular stuff. New file 4. Now, when you created this new file, because you asked Git to track it, it will realize that you added a new file to working area. Working area is nothing but your folder. This part only, not this. .git is for internal purposes. So if there is something a change, Git knows it, but it will not tell you. But if you are changing something in the working area, it will know it. So we have added new file 4 now. We have to see whether Git knows about it or not. And what's the command? The next command we have used already, git status. So here, go to git bash. We will execute the same command, and we will see if Git will tell us a new file 4 is added or not. So I'm going to clear this screen. Clear. What's the command? Git status. Perfect. You see the new file we have added? Git knows that you have changed this directory. It knows it, means it's tracking your directory. It is also telling that, okay, fine, you have added it, but if you change something, I am not tracking it yet, which means you have to tell Git, go ahead and track it. So coming back to our 3-tier structure here, 3 trees. This is the most important thing, guys. Everything about Git's understanding is in these 3 logical things. You added a file here logically, means Git knows that you added a file. But if you make a change to that file, in this case, new file 4, do you want Git to store that change somewhere or not? That you have to tell. How do you tell it? That's our next command, add Git. So you are telling Git to track this new file by executing a command, git add the file name. Let me execute that command quickly. So now you tell Git, so git add new file 4.txt. So you are telling Git, if I make any change to this file, you track it. And the way you're telling it by giving a command, add. So when you say add, where is it adding? It's adding to the index area. It's also called staging area. So what you have on index area, there is a tree. Let me write a simple line here. So there is a tree here with all the files that you want to track. So this is a tree, let's say. On this tree, you have a lot of, a big list of files. Let me write the list of files here. So here, this is one file. This is another file. This is third, fourth. So I'm just writing a list of files. So this is another file that you want Git to track. This is another file you want to Git to track. So Git has a list of files that you asked it to track. How does Git know about this list? So you did a git add new file 4.txt. When you did that thing, it added it to the list. So this index area is just like an index. Index is a list, isn't it? What's an index? How does an index look? This is an index, a very simple thing. This is just a list, isn't it? Index is a list. So the index area of Git also is a list. What is this list about? List of files and directories that Git is tracking. Now remember this thing, observe this thing. When you add a file, Git is not tracking it. It will tell you very clearly that, yes, you have added this file, but I am not tracking it. It's an untracked file. If we want Git to take that file from here and add it to the index, means if we want Git to track it, you need to tell Git by doing an add. So that's our second command. So when you do git add new file, so what happened now? Basically, it took new file 4 and added it to the index tree. This is called a tree. Now let's do a git status. Will we see new file 4 here as under untracked files anymore? We won't see, right? Because we've asked Git to track this file. How did we ask? We executed the command add. So when we say add, you are basically saying, boss Git, go ahead and track the changes to file 4. Then Git makes a note of that thing. Okay, this guy asked me to track any change to this file. Apart from this file, I am also tracking a lot of other files. So I'm making a list of all the files and directories that I'm tracking. Where is that list of files and directories that I'm tracking? Under staging area. Make sense? Now, the most important. So far, it's tracking, that's fine. Let's say you made a change, like we did last time, here, to your Java code. And you're extremely happy with your change. You thought this is the best code that anybody can write. Now you want to store this version. You want to store this version permanently. And later you might change it to 3, or if somebody asks you to change it to, instead of hello world, if they ask you to change to hi world, that's fine. But now you are extremely happy with hello world 2, and you want to store the version, not change the file. Remember that thing. You're not changing the file name. You're not allowed to change the file name in your source code. The file names are fixed because the class names are fixed. But the contents of the file keep changing. So every time you make a change, you want to store it. And when you want to store it permanently, you need to tell that to Git. And how do you tell it? Git commit. That's our next command. Let's go back to list of commands. We did an init, initialize the Git. That's when the .git directory is created. Then we looked at status. Git will tell you what files it is tracking, what files it is not tracking. This is the syntax. This is what you are saying. These are the files that are there but not tracked. Then you did a git add. Let's see this thing, git status now. You see this thing? Changes to be committed. So basically it's saying there is a new file in the staging area here, but it's not permanently stored. So means Git knows that you're changing something or it is tracking something, but it is not stored permanently yet. So what it is saying? Changes to be committed means, boss, if you want me to store this file permanently somewhere, the current version, tell me to store it. Right now, I know what are the changes happening to this file. I am tracking it because earlier you asked me to track it. When you say add, you're asking Git to track it. Now Git, when you do ask for a status, telling, yeah, I am tracking it, but I did not store it permanently. Changes to be committed. They are not committed yet. If you want me to commit it, tell me. And how do we tell Git to commit the changes? Committing is nothing but permanently storing it to your hard disk. So when you ask Git to commit it, let's clear the screen here. Git status, it will tell you changes to be committed means this file is in the index area, but the changes to this file are not committed yet. And the way you tell it is the next command, git commit. Now, when you say git commit, you don't tell the specific file. You tell everything that is in the staging directory here should be permanently stored. That's what you're saying. So it has a list of files, right? In the staging area, right? All these files will be copied and will be made into a zip file and will be stored into the local repository. And that is usually called a commit. So what we have here is in our next thing, we talked about it during the last thing. Again, I'm doing this thing. So here, git add on the working area, git stays to the staging area, and git storing to git commit. So here, let me take the same copy here. Oh. I'm going to copy the same tree. So in the local repository also, you have a tree, but this tree is not the list of files. Instead, it's a list of zip files. So this is a zip file here you have. So here, zip file. A zip file is nothing but a zipped version of all these files. Now, to make this zip file more compressed, it converts into a binary. It's called a blob. Binary large object. I think if you are in Java, you already know what blobs are. They're usually introduced to you during your database sessions, Oracle. Let's say you're storing an image, a photo in your Oracle database. It gets stored as a binary large object, a blob. But don't worry about that thing. For now, to keep it simple. So you zipped everything and stored it into a local repository. And this is called a commit. So here, in local repository, you have all the zip files, each zip file representing a commit. And how did commits come here? You did the commit. So whenever you say git commit, everything from this will be zipped and put into the local repository. So a local repository is nothing but a big list of zip files. And where is this local repository? Because this is zip files, it's inside the .git, somewhere inside it. Don't worry about where it is. You can go inside and find out where it is. That's for somebody else, means especially if you're setting it, not for you. So somewhere inside this directories, you have the zip files. So you have a local repository. So coming back here, git commit. Let's copy paste the new file. Waiting for the editor to close the file. I think this file is, let me close this. This is the VS Code editor. Something happened here. Aborting commit due to an empty commit message. Sorry. So whenever you do a commit like we did last time, you need to give a message to it. So git commit, how do we give the message? -m, the message, all right? Give any text message. This is a new file I have created. That's it. Enter. Now you see, it actually committed. One file changed. In that one file, there are 0 insertions, 0 deletions, because we did not change anything inside. We just created the file. You can see? All right. So what Git told you is, I have stored everything from the staging directory to the local repository. That's what Git told you. So from here, everything zip and gone here. Now let's change the same file and see what Git does. This is a new file, right? This is a simple text file. Let's open it. How do we open text files? You can use any notepad or any WordPad, anything. So let me open a simple notepad. Double click, notepad. So I'm putting a line in, line 1 in new file 4, just a text file, all right? Line 2 in new file 4, 2 lines I put in. Save this file, exit this file. So my file has changed. We want to know whether Git knows about this or not. Isn't it? That's the purpose of Git, right? So why we install Git and why we asked Git to track this repository, so that when we change something in any of these files, that change, we want Git to store it somewhere. Why do we want to store it? If we want it back, we can restore it. That's why we are storing each change. At this point, we have changed something in this file. Let's see if Git knows about it. How do we know about what Git knows or Git doesn't? Always Git status. Let's see what happened now. What is happening? We are on master branch. That's fine. Changes not staged for commit. What are the changes? There is a file that's modified. It's saying, this is a file we have just now modified. But what Git is actually telling is, they are not staged yet. Means they are currently in the working area, but they did not come to staging or index area yet. If you want me to track that change or put it for tracking, you need to, what's the command? Add it. Add it. So they're not staged. So I'm going to git add it, and it will go into all the changes. This version will go into the staging area here. Same process. Right now, it's telling new file 4 has changed, but it did not come here. How do we bring something from here to here? This add, all right? Then Git makes a note of that thing. And once you're okay with all the changes, Git commit. That's when it stores. Very simple process. The same loop. So I'm going to add this file. Only this file. We did not add any of these files yet. It is not even tracking. All right. So Git add new file 4.txt. Add it. Let's do a git status again. Clear it. Git status. You see this thing? What is it saying now? It's saying, yeah, I'm tracking it, but they are not stored yet. They're not committed. Boss, yeah, I know you are making some changes to this file, but they are yet to be committed. To be committed, they're not committed. So if you want to store this file as a zip commit, what should you do? Git. What's the next command to store something? Not push. We did not reach push yet. Git commit. So from here, everything should come to the local repository. You are still on the local repository. So git commit. We remember the last time error, right? Every git commit should have a message. What? -m. Now you change. Lines, 2 lines added to new file 4.txt. You are giving something very meaningful here. All right. Enter. Now see this thing. This is an important or meaningful message. One file changed. How many insertions are there? 2 insertions. We entered 2 lines. If we delete something, you would see deletes also here. All right. Any change is simply insertions and deletions only, right? When you change something, you're basically deleting something or inserting something. That's all you're doing. So here, Git said, I committed everything from the staging area into the local repository, right? So that's commit. Somebody asked me, what if you want to remove something? Perfect. So let's go ahead and remove something, Ajat. So I'm going to the same file again. Double click it. I will remove line 2. Then I'll enter new line 2 in new file 4, isn't it? I removed something and I am changing something else. You can call it whatever you want. We changed something. So I removed it and added. So go ahead, exit. What is our next sequence of commands? Git status. What is the expected output here? Okay, let me slow down here a little bit, answer some of the questions you guys are asking. If you want to remove the changes, that's what we are doing now. When we want to remove the changes, the process is still same. We make the change to the file. We add it to the staging area. Then we commit to the local repository. Here to here to here. These are the only 3 things that you keep jumping. Always. So from here, just a minute. So from here, you come here using git add. And from here, you zip everything and store it here using git commit. The sequence is always same. Git status to understand the status, then git add to add it to the staging, git commit to commit to the local repository. So change, even if you remove it, Ajat, it's still a change. The process remains same. Abhishek is asking another question. Let's see this thing. It knows about the modification without putting it in staging area by using add command. It knows about the, yes, it knows about the modification. Anything that changes in the working area, Git knows about it. But whether you want to put it in staging area or not is your choice, which means you have a directory here. Some of the files you may not want to track. Other files you may want to track. Let's look at the status. It's already happening. Abhishek. So when you say git status, even though I have 4 files here, I want to track only new file 4. I don't want to track these files and folders. I did not add these files and folders. So Git knows that the files are there, but it also telling me it's not tracking. If I want Git to track these files, what should be my command? Git add. Let's say I want to track new file 2. Then I will say git file 2.txt. sorry, new file 2.txt. New file 2.txt. So, Abhishek, the files will be there, but whether you want to track it or not, you have to tell using the add command. All right, let's execute this command because we are already here. Now do a git status. You see, it is telling you changes to be committed, means there are some changes to new file 2, but we did not zip them. Recently, we removed a line and added a new line, right? Then changes, I think this is a new file. Yeah. Changes to be staged. This is where we have removed a line and added another line. So it is telling some changes have to be committed. Some changes are still to be tracked. And some changes are not even being tracked. Means each vertical or each tree, it is telling you the status. At the very bottom, it is telling you, boss, these files are in the working directory, but you did not ask me to track them. So I am not tracking these things. Then this thing, boss, this file had changed, but you did not add it to staging. Then the first one, boss, fine. You made the changes. You asked me to track it, but you did not store them at. They are to be committed. So Git always keeps talking about these three areas: working area, staging area, local repository. Make sense? All right. So here, yeah, then what is the use of add command? Add command is specifically saying whether you want to track it or not. Means if you want to store it in future, you need to add it. If you don't add it, even though Git knows about the change, it will never zip it. So add command is basically to take your changes to staging area. And when you do a commit, only things which are in staging area will be zipped. You cannot do a commit directly from here to here. That's not possible. I think somebody asked that question also. Why from file? Why not directly commit? Yeah, commit will happen only from here to here. Commit will not happen from here to here. The reason is you may not want everything from this directory to be zipped here. So you need to tell which of the files from the working area you want to track and zip. So somebody asked me, why do we need this? Why can't we do a commit directly from here to here? That's a good question, isn't it? The reason is I don't want everything from here to go into zip file. I want only some of the files. For example, in this directory, I want only 1 and probably 4 only. I don't want to store 2 and 3. They are temporary files. I'm going to remove them after today's work, that kind of thing. So I'm storing only this thing. Or let's say you wrote 2 different class files. All right. Welcome home.java. And then, okay, not this thing. Change this. This is one Java file, let's say. I have another file also. Welcome1.java. Welcome1.java is just a temporary file I have created. I'm doing some experiments. I don't want this welcome1.java file to go into my local repository zip files. I don't want to really store just a temporary file. That's why I cannot do a direct commit from working to this thing. I will add only one of these 2 files, which is this one originally. I won't track the temporary files. All right, so that's your answer, Abhishek. Why not directly commit? How to roll back in any changes, we will talk about it. That's a commit revert thing, it's called. Can we get the video of this session and the last video session? Yes, you can. I think I posted that video. Sangam, this is the video. If you are looking again, this is the video URL. This session's video also, you will get it. By evening today, you should get that. Fine, let's get back here. I'm again repeating the same 3 commands, guys. Let me write those commands again quickly for your reference. The very simple are the most important Git commands. You don't have to know anything beyond these 3 things. Git status, to understand status, or even before that, to convert a small directory into a Git tracking thing, Git init. Then you say Git status. Then Git add, which will add files to staging area for tracking. Then Git commit, which will zip and put it into the local repository. So these Git commits. Now another command related to it is Git log. Let's see that thing. There are some committing messages here. You can keep them as they are. All right, I'm going to keep it just for your understanding. So clear the screen. Git log. Now tell me what you are seeing here. Read through this thing and tell me what you are seeing here. Abhishek, I'll answer your question in a moment. Let's come back here. So git log command, what is exactly it's doing? What's the output it's showing? It is showing you the commit ID. You see the hexadecimal number here you are seeing? This is called a commit ID. So each time you zip something, you're basically giving an ID to it. Why do we normally give IDs to anything? Your college ID card has an ID associated with it, not just your name. Your name is always there, but it also has an ID number, something like that associated. An ID generally is unique in nature. There is no repetition. Whereas your name probably can be repeated. Maybe there is another person with the same first name and last name also. Narendra Modi. Can there be another Narendra Modi? Yes. But if we attach a unique ID, an Aadhaar card number to Mr. Narendra Modi, our Prime Minister, that becomes unique. And every other Narendra Modi will have a separate Aadhaar number. So this thing, the same way, an ID is unique so that we can refer to all the changes that we did in this commit at a later point of time. Let me rephrase again. What is a commit? It's a zip file. What do zip files normally have? Bunch of other files which are zipped. So if I am retrieving this commit at a later point of time, I'm simply downloading a zip file that I made now, isn't it? And in that zip file, I have all the files which I have changed. So essentially what I'm trying to do here, anytime I change something, all such files, I'm making it a zip file and storing it. That's all I'm doing. Logically, Git is very simple, right? Isn't it? What we are doing, you made a change, fine. Take a copy, zip it, store it. It's just like uploading to your G drive. Only thing is, you are not doing it manually. A software is doing for you. That software's name we are calling a Git. And you're learning some 10 commands to do all this storing, tracking, retrieving, and changing all those things. That's all you're doing. Git is really nothing great, or it's not doing anything extremely smart. It simply zips everything and stores it. Let's go back and answer some of the questions. It's already tracking without add command also. It's not tracking, Abhishek. It's just telling you that I am not tracking. See this thing here. Git status. It clearly says untracked files. It simply knows. Knowing is not tracking. Let's say if I have to track somebody, I have to know everything that they are doing. If let's say today you are going to coffee day. I just know that information. I don't really know when you are going, which coffee day you are going to, what you are doing at the coffee day, what you are talking at the coffee day. That is tracking. So that will happen only if you do an add. All right. I think that example would give you some clarity. Every commit, Anusha, will have an ID, means these many versions. Is that right, sir? No. Commit is, let's come back here to Anusha's question. Every commit is not a version. It's just a zip file. This zip file will have a lot of files in it. Usually, each file has been changed. That's what it means. All right. A commit is not a version. A commit is simply a zip file. Inside that zip file or inside that commit, you can have a lot of files. Each file is a copy of changed version. Visualize it like a bunch of files zipped together. That's it. All right. That clears you out, Anusha. That's thing. Next, Ajit is asking, it is a physical zip file. Yes, it is a physical zip file, extremely compressed. But the extension will not be a .zip. Somebody is asking, let me pull that thing here, just so that you also are familiar with what's happening. So somebody is asking me, Ajit is asking me, it's a physical zip file. Yes, it is actually a physical zip file, but it's not .zip extension. It's a binary file. Only a Git command can unzip it. It still knows about modifications without adding. No, it does not know. It simply knows that it is being modified. It does not know the actual modification. Can we rename the file name with which was committed earlier? Yes, but it will realize that you deleted a file. This is a very good question. Yes. Prathamesh is asking, can we rename? Yes. But what does a rename mean? That's a very good question. Interesting thing. It usually happens. Can we rename a file? Let's see what happens quickly. Let me drag it. What's a rename normally? Deleting and adding a new file, isn't it? Let's say new file 4. I'm going a little fast here. Stop me. Git status. Let's say this file, new file 4. I renamed it. All right. How do we rename a file? Let's go back. New file name, rename it. When I rename it, new file 4 renamed. I renamed it, right? Which means I've deleted new file 4 and created a different file. That's what rename means from a system's perspective. System does not know you renamed it. System simply thinks that, okay, take the content, just change the pointer. That's what it does. So Git, the way Git looks at it, look at the status. Prathamesh. What Git thought is, okay, you have deleted this file. And it added a new file name to untracked files. I'm saying, okay, fine, this file is not there anymore. But you seem to have added another file. Now, if we want this file to be tracked, what do we do? Simply add. Perfect. So we just do git add to the new file. Then our new file gets tracked. Make sense? Perfect. Let's go back to a couple of other questions. Quickly answer. You guys have a lot of questions. After committing, is there any chance to modify the files? Yes. Every modification can be zipped. Okay, you are asking whether you want to modify the zipped version. No, not possible. When you did a commit, what is happening? You made a zip and you stored it somewhere. If you modify the original file, let's say this thing, if you modify the original file, this thing, all that you can do is you can create another zip file only. The previously stored zip file, you can't change it. Oh, not too much. Amar is asking another question. I have cloned the main branch, made changes to the code. Now I want to create a branching thing. We did not reach that stage, Amar. Give me some time. Once we get into branches, I will talk more about branches. All right. To answer your question, you clone the main branch. You can't clone the branch. You basically clone a file. Branching is not really, does not have the concept of cloning. I will talk about that point when we reach there, Amar. Then to show the zip file, Ajit, showing the zip file can be done, but it's a little too advanced for this session. We will stick to the basics. Connect to me offline. After this session, I'll show to you how to look at the zip files. Coming back here, guys. Sorry about that diversion over there. Going back. So far, what we did, you understood the general structure, right? So you made changes here. You want to track them. You add them to the staging. You want to store that version. You commit. Add, commit. Add, commit. When you add, it comes to staging area. When you commit, it goes to the local repository. Same stuff. Now the most important thing, we're essentially getting into the actual stuff for today. Everything that you are doing so far is locally available. It's all local. Try to understand this concept. It's all local. You did not upload these zip files or versions to internet. They're not there anywhere outside your laptop. But if you are a Java developer writing a nice Java code, or any developer, you're not working alone, right? You're working in a team, isn't it? So when you have a bunch of team members who are working along with you, your code has to go to somebody else. So let's say you're working with team member. Let me drag an icon or something. Yeah, I think this looks good. You're working with a group of people together. You're not alone. Your team members are sitting in Hyderabad, Bangalore, New York, Japan, everywhere. How do you send your code to them? How does your code get integrated with their code? So far, your code is sitting in your local repository, which is this .git directory. This has to go outside your local repository. Just give me a moment, guys. We will take a break. I know you're a little bored Sunday morning. So here, I'll introduce an important concept, then we will take a break, and then we'll continue the concept after. Put it into your head a thought that, yeah, everything I have written so far is on my laptop. How do people outside my laptop, for example, my team members, know how great I am? What a beautiful code I have written. If I can't show it to them, they don't know about my code. Why do we take so many selfies? to keep it in our mobile or to send it to our friends. We can all feel that impulse, right? You're taking a selfie right now, some of you. You're sending it to somebody or uploading it to Instagram. Others have to know how great you are. That is talking, we are talking, I'm simply talking about a selfie. Now, this is Java code, pure Java code. So unless you send it to somebody, you won't get your salary also. Which means this code has to go outside your laptop, outside this .git directory. Only then it's useful. Otherwise, all the commands that you learned so far are only within your laptop. They are simply tracking changes in your laptop. Yeah, you know about all the changes that you have done, but unless you send the changes to somebody, unless you send your beautiful these 4 or 5 files that you just now created to somebody, you're not really, the whole Git point is not useful, right? So what we want to do now is, we want to send these files, not the .git directory. Or you can send that also, not a problem. But this whole directory has to go to all my team members. And that's when your next components in our session comes in, or GitHub. GitHub is simply a website on the internet which implements the exact same Git that you are doing here with little additional advantages. We will see those things in a moment. So what we have here is, you have a local repository. You can send your local repository to your remote repository on the website GitHub. Just like GitHub, there are other remote repositories also. Like I think Anisha or somebody asked, what are the other repositories? gitlab.com, bitbucket.com, .net, that is. Let me show you those things quickly. So GitHub and gitlab.com. This is a second such company which allows you to upload your local repositories like these things and give it to your friends. So this is one such website. We will see that. What's the third one we are talking about? Bitbucket. Bitbucket.com, .net, everything works. GitHub, GitLab, Bitbucket. This is bitbucket.org, sorry. Just give it a moment, it's loading up. That's your Bitbucket website. All these websites, what they do, they allow you to upload your local repository online. Why do we upload something online? For others to see it. They should know how great you are. All right, so let's go ahead and take a, how long you need the break for. When you come back from your break, we will talk about how to push our code from our local system to your Git repo, and then how to allow others to see your code. That would be your second part. How long we need the break for? Bitbucket tracks only test files? No, Bitbucket is just like GitHub. Whatever GitHub can do, Bitbucket also can do everything. Can we stage a file without adding in the zip file? Yes. Yeah, then you need to discard the stages. Salman. You can do a staging, then you can choose not to track it. That's possible. Bitbucket tracks only test files. No, it tracks everything. Gitignore. Yeah, Gitignore is a file where you have a list of things that you don't want to track. For example, if you have file 2 and 3, you don't want to track it, you will put these two numbers or these names into .ignore file. So I haven't talked about .ignore at this point of time. Maybe we will add it later. Right now, yeah, that's all for now. Take a break. 10 minutes fine. Too short. 10, 15, 20. Let's take, that be okay? 20 minutes fine, right? So 20 minutes break. So we will meet again at 10:25. All right, 10:26. Right now, 10:06. We'll take a 20 minutes break. 20, 20. You're going to have your breakfast now. Skip the breakfast for today. Have your lunch directly. So I'll meet you back at 10:26. Right, guys. Thank you very much. Shall we start, guys? Can you hear me? Can you hear me now? All right, guys, let's start. So before we stop, before the break, we were talking about how to take your code from your local repository. The local repository is the third stage in the three verticals. You see this thing here? That's where we put all our commits, the zip files. So this set of zip files, we have to take it online so that your team members can look at your code, can integrate your code with their code. And if there are issues on your code, in other words, bugs, they can fix it. So let's look at the three reasons why we take the code outside. One is look at your code. In other words, it's called review your code. Second thing is to integrate your code with others' code. What is integration? You will be adding your code with others' code so that everything becomes a complete application. For example, let's say you are a developer for Amazon and you are working on only specific component like this cart, shopping cart, it's called. This shopping cart is what your team is working on. So if you write your code only related to shopping cart, that code has to be integrated with general website, isn't it? So that is called integration. So coming back, that's the second reason why you want to send your code online. And third reason is to find out bugs. Let's say you wrote the code and you could not write it properly, or you accidentally left a bug in there. So to do these three types of things, we normally send our code from your local repository into a remote repository. Now, so far, we looked at a simple directory and we assume that's the code. A similar code is usually what gets created when you use your Eclipse also. So when you say project, it's something like a simple hello world project. Your Java code basically is in the source directory somewhere in just a directory structure. Yes? All right. So any code, whether you write it using a simple text file or whether you write it using your Eclipse everything will be stored on your system in this directory structure. And if you have initiated this directory using Git, you will see this .git directory. And then we have seen the list of commands. Let's go back to the list of commands. This is something that you may want to remember. Init, status, add, commit. We did not come to push add. We've added another command here, git log, which will list out all the commit messages. Let's quickly run this command, git log, clear it, git log. These are the commits which are currently in our local repository. All right. Now we want to send it to the remote repository. So the local one is this. What's the opposite of local? Somebody said global. That's also correct. But right now, this is usually called a remote repository. In this case, github.com. Instead of github.com, you can use GitLab also, Bitbucket also. Now, before we start using any of these websites, let's try to understand what that website is. Now, to understand it better, tell me what Amazon website is. What kind of application this website represents? What is Amazon? Is it just a website, or is it a Java or some other application? Application? If it is an application, what type of application it is? Fantastic. E-commerce application. Anything else? Anything else? A web application. Yeah, that's from a technical standpoint. It's a web application. But from a business angle or from a functionality perspective, it's an e-commerce. So you can buy many things from this website. It's a distributed application. Yes. Atili says it's a distributed. Yes, most of the applications nowadays are distributed applications. You have a front end, then you have a back end, and then you have a database. So the three-tier architecture gives a distributed application. Viraj. Abhishek says marketplace. Yes, it's a e-commerce marketplace. Correct. Fine. Fantastic. So looking at your answers, especially the e-commerce and the marketplace, you are telling there is a specific functionality associated with each website, right? Let me give you another website. Something like PayPal. How many of you know PayPal.com, or all of you know Paytm, right? What kind of website this is? There is a functionality behind this website. What is the functionality behind this application? Anybody? Transactions. Okay. What kind of transactions? Digital transactions. Correct. Digital transaction, more specific? Anything more specific beyond digital transaction? Is this not a digital transaction, e-commerce? A transaction of goods happening digitally. You're buying a book, but you're buying it online, digital. This is also a digital transaction, but How is Amazon is different from Paytm? Digital transaction, Abhishek says. Go ahead, and we need more specific functionality of Paytm. The digital financial transactions, which means once upon a time, if you compare probably 10 years before Paytm came in, people used to give money to each other, notes, bank notes. So you give me notes. With Paytm, the application, after notes came banks. All right, you have a bank account. You are able to transfer the money from your bank account to others' bank account. That happened before Paytm. Paytm made it possible using your mobile app. So it basically connects to your bank account. The Paytm itself is not a bank. It cannot really do or touch your bank account unless you allow it. Payment gateway, correct. Payment gateway is another way to put Paytm at. So here, what we are really discussing, UPI, that's correct. That's one type of medium to transact money like NEFT, IMPS, RTGS, UPI, Unified Payment Interface is one type of payment. So this is a financial transaction. So every time you look at a website, you have something happening on the backend. That's a functionality of the website. We talked about two such things. One is Paytm, which allows you to do digital transactions. The other one is Amazon. So here, we looked at two different things. Let me copy paste it. So here, Paytm, and this one, Amazon. Paytm, you said Amazon, you said e-commerce to buy and sell goods. Paytm is to transfer money digitally. Now the same way. So what you're saying here is for every website, even though it opens a simple page, there is a specific functionality on the backend, the application design. The same way, I want you to think about github.com and tell me what's the functionality that this website provides. What exactly these guys are trying to do or trying to give you. Amazon tried to give you an application using which you can buy and sell goods. Paytm tried to give you an application that can connect your bank account to somebody else's bank account using UPI interface. The same way, what is GitHub trying to do? Think of it for a moment and tell me what GitHub is trying to give you. What is the functionality of the application which is behind this website? Secure storage. That's a good point. Storage. All right. So let's look at the functionality of GitHub. So one of our students says, GitHub is for storage. Correct, that's true. Anything else beyond storage? Because storage is available on G drive also. Is it not? But that's a good point, storage. So GitHub functionality, storage, very good. Anything else that GitHub is providing? Transaction history. Okay, what does that mean? Transaction history. That's good. Transaction history, that's good. Can I say change history? Would that be more appropriate? Instead of transaction history, can I call it change history? In the context of Git, anything else it provides? Security. Security for what? Anusha, security for what? That's a good thing. Security for what? The third point we are talking here. It provides security. That's also correct. So security to your code. Is that what we are saying? Fourth point, version control. Does it provide version control? Okay, that's also true. Version control, basically, we are saying GitHub itself is a Git, isn't it? Anything that provides version control is usually a Git repository. So even GitHub, we are saying Git functionality. Data security, confidentiality, correct. That's good. So data security and confidentiality. That means if you put something on github.com, it's guaranteed that it is not given to others without your approval. That's a good point. Anything else? Management. Management, that's good. Any specific management? Management of what? Satamesh is management. Management of what? Management of our data or management of users we are talking? Task management. No, it does not provide task management, not necessarily. Let's say management of user access. We will talk about it in a moment.
Project
Hence,
management.
some users can have only read-only access to your data. Some users can have edit access. Some users can have other types of access. Projects is not really a functionality, it's more like a feature. We will see that. All right, looks like you summarized pretty much everything, the key important things that provides. So GitHub, first thing, storage. Yes, you can store your code on GitHub, but storing alone is not really of much use. You can store it in G drive also. All right. So beyond storage, it also provides transaction history, means what are the changes you are doing to certain things. It provides security to your code so that nobody can take your code, nobody can access your code. Version control, yes, it provides Git functionality. Basically, what we are doing is we are transferring our code from the local repository to the remote repository. So here, let's come back. So from the local repository here, we are sending it to remote repository. That is provided by GitHub. Other couple of things, data security, confidentiality, true. Your data is secure. Nobody can access it without your permission. And also it provides user management, and in other words, called access control. Means who can access your data, who cannot access your data can be decided by you. We will talk about all those things in a moment. At the summary level, the most important thing GitHub provides is a remote repository. So basically a Git functionality, but available online. So you can do a Git add, Git commit on github.com also. You can create a repository on github.com also. So everything that we have done so far here can be done here also. But we don't want to do the same things on remote, not necessary. The most common usage is take your local repository, send it to remote location. That's what we are doing. And the command to do that is, which is our next command in our list. Any guesses? Git push command. So when you say git push, you are pushing your list of files from the local repository, which is here, your third vertical, to a remote repository, which is one of these three things. Only one at a time. You can, of course, send it to everywhere, but there is a link that you establish between local and remote. We will send it. All right. Now, to understand the GitHub, we will go in a systematic way. Let's go ahead and write down the list of tasks we are going to do on GitHub. So first thing, I'm going to create an account. This is a free account you can create. After you created a GitHub account, you create an empty repo or repository, add some files, commit the files on the repo. Now the important thing, clone the repo from remote to look. Then add some files to local repo. Stays the files on local repo. Commit the files to the local repo. I will give an explanation to each one of them in a moment. Then finally, push the local repo to remote, which is github.com. Make sense? That's what we are doing. Let's try to understand this pictorially, what we are trying to do here. Create an account on github.com. So this is your github.com website. We can create a simple free account. You just sign up. When you sign up, you get your regular normal sign up stuff. The same thing can be done on gitlab.com and Bitbucket also. Let's try it on github.com. This is the most popular of all remote repositories. Looks like there is an error. Let's try it again. github.com, enter. All right, sign up. Click sign up. Those who are online, offline, anywhere, you can try it on your laptop or also on mobile. If you already have a GitHub account, that's fine. You can log into the same GitHub account. If you don't have it, go ahead and create it. It's a free account. You can do it on mobile also. Looks like there is a problem with GitHub website at this point. It's not working. So while this comes up, let's look at the list of things we are planning on doing. So we're going to create an account on GitHub. So let's say this is your GitHub. This is your GitHub on the right side. And this is your local repo. Let's put it the same size. So this is local Git. This is remote Git. In other words, github.com. So the first task is to create an account here. We tried it on github.com website. Looks like there is a problem. We will come back to that in a moment. Anisha is asking, is that secure since we are putting on remote? No, not because we are putting it on remote. The GitHub website provides security measures like encryption, access control, identity management, that kind of thing. So create an empty repository. We haven't done it yet because the account is not created yet. Add some files, that is also pending. So here, let's see that. So create a free account. So we're going to create a free account here first. Then we're going to create a repo here. For sure. Create repo. We're going to do that in a moment. Add some files to the repo. So add a file. Add a file. This we are going to do on remote itself. Then commit the file to the repo. So we're going to commit the file also to the repo. After we commit, then clone the repo from remote to local. This is interesting thing here, guys. So here, look at this step. What is cloning means? Prathamesh, you are able to access GitHub. Yeah, it should get fixed. We'll come back to that. So what is cloning? Step 5. Try to understand step 5 before we do it. What is cloning? Cloning in general. Copy. That's correct. Creating an exact copy. Any other keywords for cloning? So one keyword is copy. So copy. Any other keywords that come to your mind about cloning? Replica. That's correct. That's another one. Replica. Replica is a very popular word used for cloning in that context. Anything else? Duplicate, somebody said. That's also correct. Excellent. All right. They basically summarize Xerox. Xerox. That's good, huh? That's good. Xerox. Is Xerox cloning? I don't think you get the exact copy of Xerox. Huh? If you take a color Xerox, probably it's a clone. Is it? That's a very good way to put it. Xerox. So when you take a Xerox, you're basically doing a copy of an original one, an existing one, or you're taking a replica of something that exists. All right? You're creating a duplicate. So we got the gist of the clone means. So what we are saying here in this step is clone the repo from remote to local. This is our remote. All right. So from remote, this is our local. So from remote, whatever we have created so far, these things, we created a remote repository, we have added a file to it, and we committed it, which means it's available on the remote. And we are doing a copy of this repo to local, to our laptop. We are bringing it. In other words, you are downloading it, isn't it? Is that what we are doing? In a way. So you have a remote repo and you are cloning it to your local Git. You're basically downloading it. Instead of download, I'll say clone. That's our fifth task. What's our next one? Add some files to local. Correct. Local now. Earlier, we have added this file to remote. Now we are adding it to local here. So we add another file. So here, add file. Now, when we add file, we know what to do. Those are the next two common steps we have seen. We stays it. How do we stays it? What's the command to stays a file locally? Git add file name. That's a staging command. And after staging, what we normally do? We commit it. That's our next step, isn't it? Commit that file. So git commit everything from staging. Git commit -m your masses. That's our sub steps of 6 tasks we're about to do. And so everything is available here local. Then we will push the local repo to remote. That's going to be our last step. So what we are doing summarily, we are creating something on the remote repository on a website called GitHub. On that repository, we are adding a file, we are committing a file. So now our repository is only available remotely. There is nothing available locally at this point of time. Then we are cloning it. We are making changes and pushing it back. What is -m? -m is a message. So commit git commit -m, the message which is about to come in the quotes. All right, let's go ahead and try to do these commands. All right, I'll just remove whatever is not necessary. All right, so step 1, create a free account on github.com. Let's hope github.com is available now. The sign up is, yeah, this is a sign up page. It's really, really slow today. Yeah, it's typing something. Enter your email I think I already created it. I'm just going to create. I don't think I can create it, but let me show you the process. I think it will say it's invalid. Invalid already taken. Let me give. There is no such web. Gmail.com. Okay, continue. Password Durga123. I'm not going to create an account, guys. The account creation process is pretty simple. I'm just showing you how it can be done. Password may be compromised, not a problem. Continue. No. Give some password. Durga. No, it requires a strong password. So we're good for now. Continue. The password is in the list of passwords commonly used on other websites. Tell me some nice password, guys. It's not visible. Hold on, guys. Yeah, sorry. Yeah, there are some nice recommendations here. Chiranjeevi, Avatar. Okay, I'll try to use one of those things. Avatar. Okay, let me try to use Avatar. AVATAR. Too short. Make sure at least 15 characters or 8 characters, including a number and lowercase. Avatar. Two. Oh, now we are getting password strong. And you can also see password continue. So just make sure password is strong, guys. So this is the password I'm trying. Avatar 123 6 twos. Seems to be okay with it. Click continue. You give your username, anything. Let's say Durga Git 123. Then it's available. Continue. Would you like to receive product updates and announcements via email? No, I don't want any updates. My mailbox is already full of spam, so I don't want any updates. Continue. Next thing, verify your account. Please solve this puzzle to verify that you are human. Start the puzzle. Okay. Pick one square that shows two identical objects. Guys, can you pick up? Which one? Can you see?
Third
You
one,
can't see
sir.
it,
Third
right?
one.
That's a dark website. Which one, guys? Those who are online?
Third one, sir. Third one.
Looks
Yes.
like the third one.
Yes, sir.
Yeah. Done. Again, another image. Pick one square that shows two
Second one, sir.
identical objects.
Second one.
Again, which one?
Second,
Second one. That's good. Sundar. Sundar is the only guy who seems to be active today afternoon. Yeah, good guys. Verify your account. Create your account. It sends out an email to your mail ID. You enter your code that you got, and then you create your account, right? I don't have this email ID, I think. Or do I have it? Let me check it. No, I don't have it. I just gave a random email ID. So if you have that email ID, you would get a 6 or 8 digit code. This is 8-digit code. You will enter it and you log in. Now, once you created this account, let's log in. I'm going to log in with another ID. So github.com. Now you sign in. Account verification, leave this thing. So we are, why is it? It can't go beyond verification. I'm going to log into another account, one of my previous accounts. This is how it looks like. So sign out, let me log in again. So sign in here. This is what you would get, a GitHub web page. You log in with your username, password that you just now created. I'm using one of my old ones. Sign in. This is the initial page of login. You may see a slightly different one, but usually this is what it is. Now, once you log in, let's try to quickly understand some features or important features of GitHub. I'm going to list out all those features. All right. So here, so sign in. A second thing that you're going to look in after you sign in is repositories. We are going to see the important features of GitHub so that you don't, just randomly move around. Repositories. Why did we create this GitHub account in the first place? To create repositories, right? We wanted to store our local repositories into a remote place. That's the second and most important thing that we have to do, isn't it? So let's see how we can see the repositories. So I'm going to close all the other websites just to make things easy for you. So let me close everything else. So I have our whiteboard and the GitHub page. Now the repositories are available under your profile. You see it right here. Click on the right side. If you are online, you can work along with me. Here you can see your repositories. This is where every repository that you create gets listed. So click on your repositories. Don't worry about the remaining things like organizations, projects that will come later. Now, if you see this repository, this is where the list of repositories are. You can see it here. There are 58 repositories in this account. And the names of the repositories you can see here. All right. These are the repositories I've created over a period of time. On the left side, you see your profile. You can upload your nice image and everything. It's just like your Facebook profile. Nothing really complicated stuff here. What we are interested in here is repositories and how does a repository look like? Let's look at one of the repositories. So here, Linux commands is one of my repositories. So if I click here, it opens up my repository. What any repository will have? It's a group of files, isn't it? So any file, any repository, just a bunch of files, nothing else. In this repository, if you see, I just have 2 or 3 files in here. Now, out of these files, the first 2 files are really important files. Gitignore, that is G.gitignore, Gitignore. Gitignore is a file which is usually available here. All right. You can create it here. What it signifies is, we just now seen that we want to track only some files, but we don't want to track other files. Let's say I want to track only file 1 and file 2, but not this thing. Isn't it? So what I can do is, I can simply create a .ignore file, gitignore file here. So I'm going to create a file .ignore, sorry, what's the file name? Gitignore. Enter. It says the file extension is starting with, there is no file extension. Are you okay with it? So I'm okay with it. Now in here, let's say I don't want to track file 1. What will I do? I'll simply put the name of the file in .ignore. That's it. What am I doing here? So I'm listing out everything that I want Git to ignore tracking. Now, if I say, let's come back here. What's the current status of Git? Git status. It is saying, boss, I'm not tracking. Welcome home.java, welcome home1.java. Now let's say we ask Git not to track this file. You are telling, don't track it. Then it will not tell you that I am not tracking, because you are already telling don't track. So I'm going to add this welcome home1.java to gitignore file. Copy that file name, go to .ignore, put it over here. Save this. Now if I run git status, what's the expected output? Git status. Do you see welcome 1? Earlier it was there. Why did it miss? You told Git don't ignore these files. Sorry. So what Git is doing is, every file that is available in this directory, it is trying to tell you the current status. Means it is trying to tell you whether you want it to track it or not. If you don't want to track some files, you have to tell Git, don't track it. And how do we tell it? You simply put gitignore. Let's say I don't want to track folder 2. All right. I don't want to track folder 2. So what I'll do, simply put this folder name in the .ignore file. Make sense? You have a lot of files here. Only some of them you want Git to track. Others you don't want Git to track, or you want Git to ignore. You're saying ignore this file. You just now told ignore this file, or ignore this directory. Or you can say ignore all .class files, star.class. Ignore all MP3 files, star.mp3. So Git gives you a very nice way to tell it to ignore files or directories. I am trying to ignore directory, or anything that ends with a dot class, star dot class. Regular expressions. Star dot class, which means if you have a dot class file in this directory, and because he told Git to ignore all classes that are ending with dot class, so it will ignore. Like this, you can put anything you want. Store dot images you don't want, or anything you want Git to ignore, you simply put it into that file. And this file gets created here. So now if you see here, Git status again, we don't want to track folder 2. We just now added it, right? You see, the Git ignore, did we add new folder 2? Which means new folder 2, you want Git to ignore. So it won't tell you anymore that this is an untracked file. Git status. Status, spelling mistake, sorry. Git status. Right, you see, it is not telling anything about Git folder 2 anymore because you asked Git to ignore that direction. So Git ignore is a very interesting file. It's a text file, right? Which has a list of files, directories, extensions that you want Git to ignore. That's Git ignore. All right. So that's one interesting file. Let's save it and store it. Let's get back to our repository. The other one, readme file. Readme file is the most common file, or very basic file. Can Git ignore .git ignore itself? Yes, it can. That's a good point. So if you want Git to ignore changes to this file, what should you do? You put the name of this file inside this file itself, isn't it? .git ignore. Very good. Exit. So you asked Git to ignore .ignore, which means now it will stop telling you about .git ignore. It is not tracking .git ignore anymore. Arjun, you clear? Fantastic. Same thing. So anything that you want Git to ignore, open this file, put that exact name or a regular expression representing that thing if you don't know the exact name. Fantastic. Now let's go back. We're talking about readme file in a repository. This thing, all right? A readme file, as the name itself says, it is asking you read me first. Now, usually readme file tells you about the contents of that repository. If you see this thing, it says basically about, this link is about something, blah, 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 whatever it is. If you go down, you see the structure. There is a title, then there is some text, commands, then there is some text, which is a regular text. Now, this syntax is what this .md represents. Any guesses on what .md is? Like .java, what is .md? Any guesses? The whole Git, all files are usually .md files. Any guesses on what .md is? .md is a markdown file. It's not plain text, it's a markdown file. You will see that .md very extensively. So we're talking here about third one. in the repositories .gitignore, sorry, Gitignore file we talked about. A fourth one, readme.md. MD is markdown syntax. It's a specific type of syntax. Let me show you something. Markdown, how it looks like. I'm opening one of my other editors, code editors. Visual Studio Code Editor. Only to show you how a markdown would look like. I need to reduce the size of this. How do I do that? Few ones. Yeah. Zoom out. All right, this is one of the files. Let me show you how a markdown would look like. Yeah, this is one of the files. See this thing? This file is a markdown file. Basically, you're looking at hashes, this thing. Now, when you actually upload it to GitHub, it looks something like this on the right side. Let me show it to you on the right side. Preview markdown. You see it on the right side? What's the difference? On the left side versus right side. Left side is what the actual text file looks like. I've written it to you starting with 3 hashes and then hyphen, hyphen, hyphen here. But when you actually, what we call render it, this is how it looks like, isn't it? It's like a HTML file. In HTML, what's the code you normally write? You start with something HTML, then you end with HTML, and in between you have a body, then, isn't it? Isn't that what you do? Something like this. But when you render it, how do you actually see it? You see it like a web page, isn't it? The same thing is Markdown. Markdown simply says, to highlight something, you have to do this. To make it like a bullet point, you have to do this, that kind of things. All right. So Markdown is one such simple syntax thing like HTML, which is extensively used in GitHub. Here. So you can open this file if you say. All right. This is the actual rendering. If you want to see how it looks like, means you have to see the actual text. I'm going to click on edit here, edit button. You won't be able to do it because this is not your file. This is my file. See how it was written. This is actual code of Markdown. You see this thing? To highlight something, what did I do? I used 2 underscores. To highlight something, I used 3 marks. And it looks like this when we actually look at. So code is written like this. It actually looks like this. So Markdown is a simple formatting language like HTML for coders. If you are a coder, this is easy to track. This is not easy to track. Git cannot understand that you did a bold here or a highlight here. Git does not know any such thing. But Git knows the other way to do it. If you do a 3 number sign, Git knows about it. So Markdown is a formatting language, a very simple formatting language for coders. So every file that you see here in this repo, if it has an extension of .md, it's a markdown file. And when you want to write your documentation on GitHub, you usually go with markdown. So what we have written versus what we see is slightly different. All right. But again, this is not a class about markdown, so don't worry about it. You can learn markdown when you reach that stage. Right now, let's get back to our GitHub stuff. So we looked at 2 important files, .gitignore, a readme file. Whenever you see a readme file at the top of the directory or repository, it gets displayed here. So this readme file is what you're seeing here. All right. Apart from that, I have a couple of other files. This is a regular text file. This is a YAML file. This is again a .md file, which is a markdown file. Now, if you see these things, these are the messages of the latest commits related to this file. When you are creating your commit, you are giving a message, right? Using -m. That is this thing. Somebody asked me why we give -m. We give -m so that when we see it on a repository, we know the latest change to this file is related to this change. Isn't it? You see this thing. README file, the latest change, what I changed here in this file is I replaced the catacoda scenario with a killer coda scenario. So I know, okay, this is the latest change I have done in this file. So any commit message that you put is visible here. All right. Then let's look at some other things. Important things only I'm looking at. Now, if you see this thing, this is a public repository, which means anybody can see this. And the way to see it would be this URL or this URL. This green button is the most commonly used thing that on GitHub for you. So anything you need is mostly in this green button. So if you click on the green button, you see the HTTPS link of your GitHub repository. So this is your GitHub repository. You can see this entire GitHub repository. Let me post it. So that's a GitHub repository we are looking at. All right. You can access the GitHub repository from your browser or from your terminal, SSH terminal also, if you are working on a Windows or a Linux terminal. GitHub CLI is another thing. We'll talk about it probably in some future. It's not recently introduced. This is right now, it's not really that popular. Stick to your HTTPS for now. And this is the URL. And this is a public repository. What's the opposite of public repository? Private one. So we've seen 5th point, public versus private repos. The word is usually repos. What it means is repositories, but usually call it repos. All right. The full form is repositories. Let's get back here to our website. Then you can see a couple of other things here. Unwatch is basically when somebody is watching it. Means if you make a change and push it here, they will get a notification that your repo has changed. That's for watching. Let's look at a fork. What is a fork? How does a fork look like? You all know what is a fork, right? Now, when you say a fork, we're talking this thing. This is the most appropriate example, I think, here. You see this fork? This has only two these things, isn't it? So when we say forking here, this word, you can see the symbol similar to fork. What happening here is somebody made a copy of my repository. So this is the one. Next thing, sixth thing, fork. Let's quickly try to understand what a fork is. So this is your main repository. Somebody took a copy of it. Then they can make changes, they can maintain it. So at some point, if I am forking your repository, I am taking a copy into my own account. Let me do a forking to show it to you. Is fork called clone? No, clone is different, fork is different. In a way, they are same, but not exactly. Fork is basically the current state of the repo. I am taking a copy, and from them, it becomes my own repo. So let me search for any repository, open public repository. GitHub has a lot of public repositories. So Java repository, Java. I'm just searching for Java. It's searching in my repository, so I don't have any my repositories. So let me go to github.com. Not under encode IT. Let me try to search something very common. Let me go to Google. Google.com. Java repos on GitHub. Okay, trending Java repositories on GitHub today. I'm searching. Open it. These are trending Java repositories on GitHub. You see this thing? They're mostly public. You can see the programming language, the number of stars, number of forks. You see, anybody made a copy. There are 24,405 user accounts who created forks of this thing. Design patterns. So let's have a look at it. This is a repository of design patterns created by user. This is a username, Iluwater, whoever it is, representing this website, I think, javadesignpatterns.com. Now, I want to make a fork of it. See this thing. So here, I'm clicking on this button. All right. When I fork it, this website comes into my account. I'm making a copy of this thing. There's a question here. Ajad is asking if main repository something deleted, then fork repository also deleted? No. Your copy will remain with you if you have forked it. So I'm going to fork this thing, create a new fork. All right. This is what I'm going to click on. Create a new fork. It is asking you, what would you like to name it as? Create a fork. A fork is a copy of a repository. Forking a repository, this is the main reason why you fork, allows you to freely experiment with the changes without affecting the original project. Which means, let's say you have created your repo. Now I want to experiment with your code. but I don't want to change your code. So what I do is I create a fork. And from time to time, when you make your changes, I can sync those changes into my fork. So here in this case, let's say Java design patterns, I'm going to keep the same name. Copy only master branch. There could be multiple branches. I'm copying only master branch. Create a fork. So if you see this thing, now it's under my account. It is also telling me it is forked from a different original source account. All right. So fork is a copy, but your copy basically tracks the original source. Fork is not really clone. Clone is basically making a copy, but when you make a fork, you will be able to map it with your original repository, and you can do a sync from time to time. Whereas clone is more like a local copy. You have to do a pull. It's similar. Yeah, I mean, exactly not same, but similar. You can say that. Yes, Amar, that's correct. So here, moving onwards. So we did a fork. Let's move on. Let's go ahead with our some other key observations on this thing. So that's fork. This is star. If you want to star it, basically you are giving stars. Then there are branches. You can see a lot of branches. Right now there is only master branch because we have forked only master branch. This is an important thing. Pull request. We're going to talk about pull request in a moment. All right. Apart from that, all settings are here under settings. One important thing is collaborators. Collaborators means if you want your friends also or your team members also to push their code into this repository, that's what they're called, collaborators. Other than this, there are a lot of other things available here. As you get more familiar with GitHub, you get to understand all these things. For now, let's not dive too deep into it. Right now, let's stick to the basic stuff. Anything else? There's nothing much, except if you go down further, you reach what is called a danger zone. And this is where you can make a repository public or private. All right. You can also delete a repository. These are all basic stuff related to github.com. Once you start using it, you will understand it. What we are interested in at this point is code and pull requests. That's it. Remember this word, pull request. We will come back to this in a moment. And if you want to change something, we're talking settings. We'll talk about that later. How to change public to private, please show. Okay, let me show it. Let's take one of the repositories. This is my public repository at this point of time. All right. You have to own the repository. First of all, this is my repository, public. You keep the URL. Now you go into settings. We're trying to change it from public to private. You go into settings. You are still under general settings. Scroll down, Ajad, till the end. Scroll down till the end, till you reach danger zone. You see change visibility. You click on it. It will ask you whether you want to change the visibility. Currently, this repository is currently public. All right. I'm going to change it to private. Change visibility. Click it. Change to private. Can you see it? Click on it. It will ask you for confirmation. So I want to make this repository private. So click it. It will tell you it cannot be undone and all that stuff. People will lose their access to this thing. See this thing. Making this repository private could permanently erase those counts by remaining. So basically, these stars I will lose because there are people who are watching my this thing. They won't be able to see it anymore. All right. So that's, apart from that, there are some other things also that you lose. Let me not make this private. There are other people who are doing this thing. Let me change something else. Repositories. I think there are some dummy repositories I have. This looks like a temporary one. So click on temp. This is already private. Let's try to make it public. Private settings. Go down towards the end. Change visibility. Right now, this is private. Change visibility. Change to public. I want to make this public. Read and understood everything. Make this repository public. All right. Now it is public. All right. Same thing with private and public. Same stuff. You got it, Ajit? Fine. Now let's get back here again to our list of repositories. This thing, your repositories. So this is a list of repositories we are talking about. Let's get back to our work here. What is that we are trying to do? We created an account, we logged into an account, then we try to understand some basic stuff. Change private to public, vice versa. Something. Next, let's try to create a repo. All right, we create a repo, we add a file, and we commit the file. Shall we do these three things? So we are on GitHub. We're trying to create a new repository here. Let's go back to repositories here. Fork repo cannot be changed. Fork repo cannot be changed. Yes, it cannot be changed. That's a fork. It cannot be changed. If the original one is a public one, it has to be a public one. So let's go back and try to create a new repository. Your repositories you are in. So you see here, you're under repositories. Click here. You create a new repository by clicking on this green button over there. So click on that green button. You can create a repository based on a template. There are existing templates, means there are existing files, or if you don't want any existing files, no template, then you give a name. Repo for DURGASOFT, Git, GitHub, workshop. You can give anything you want. If the name exists, you usually see a green button here. Otherwise, you don't see a green button. So description, GitHub repo for DURGASOFT, Git, GitHub, workshop. Something, give something, makes it meaningful. You can choose either public or private. I'm keeping it public so that you can have a look at it. Initialize the repo with a readme file. So I'm going to add a readme file. So it will add a readme.md file. Now it's not mandatory, it's an optional one, but it's a good practice to give it. All right. Also, add Gitignore. This is also a good practice thing. So add it, template none, or there are predefined templates of .ignore file. For example, the one that we have created here, we added .class files to be ignored, right? Why did we add .class files to be ignored? Because Git cannot track compiled code. Git can track only text code. So adding a dot class file is not useful for your repository. So you simply said anything with this dot class, just ignore it. Don't bother adding it to my repository. The same thing, you can ignore .jar files, .var, .er, anything else you can ignore in a repository normally, .zip. Git cannot track these things. Git can track only text files. So accidentally, if you put these files into this directory, you don't want Git to worry about those things. You just ask it to ignore it. So this file, if you see, is a very common file that can be used by anybody if they are doing project development or code development in Java. Yes or not? So do you want to create this file every time? No, right? So that's what GitHub is telling you. GitHub is telling you, boss, I already have an ignore file for Java. Let's add it for Java. .ignore file for Java. They're already giving it to you. You don't have to create it. Perfect. .java file. So it will add a .ignore file. Very common thing. Now the reason why we can add it is, if you are working in a team and your team uses the same file every time, all the repos will be same. It will be easy to understand others' repository. So I'm adding a .ignore and .readme file also. Licensing is, you don't have to really worry about licensing unless you are into product selling or something. But generally, a MIT license is the most common licensing or most open licensing. MIT license is Massachusetts Institute of Technology. That's a university in US. A MIT license basically says you can take my code and you can do whatever you want. Right? This is your code, right? And you are making it public. When you are making it public, you need to tell people what they can do with your code. Can they only read your code or they can sell your code? If you give MIT license, you are telling them, okay, do whatever you want to do. You want to sell it, no problem. I don't care. So MIT license is the most common thing. Even if you don't give anything, that's perfectly fine. All right. Then the next thing, branch. The default branch is a master branch. We talked about it. What a branch is. Master slave model. What is the other name for master nowadays? Main. That's correct. Last time we talked about main, why we don't want to use master again, but some companies and some repos still use master. So here it is telling you master. If you want to change it, you can change it in the settings. All right. Can we restore files from .gitignore? .gitignore is not a storage. It's a list. You can delete something from that list. But if you haven't tracked something, it's not there. So there is no point of restoring it. Another, if you have put a file name into .gitignore, you're telling Git to ignore it. So it never stored anything. If you haven't stored anything at all, we can't really restore it, isn't it? You got the point? Yeah. So let's go ahead and create a repo. That's your first Git repository, guys. You successfully managed to create your repository. Only files that currently available in here are the two files that you have created. You have added the Gitignore and you added the readme default during creation. Perfect. So that's your Git. And the URL for that Git is this. So if you copy it, I'm posting it to online for everyone. Just go ahead and open it just to get a feel of it. These are all simple things, guys, but you get a feel of it. That's when you remember it. So this is your first repository on GitHub. What type of visibility it has? It's public. Anybody can see it. All right. Then there are no forks, means nobody forked it yet. Nothing much is happening here. No stars. Nobody started it. Can we start it? We can start our own stuff. Yes. Let's refresh this. Now we have a star also. If others also started, you see the number of stars. Now this is one way to tell how popular a given Git repository is. If there are more number of stars and more number of forks, it means a lot of people are taking your code. It means your code is getting very, very popular. All right. So here, let's move back to our task list. We created a repo. What's our next thing? You add a file to it. So let's go back to our repo. Now let's get a list of this thing. I'm going to close everything again. This also. So if I click on repos, I should see my latest repo. This is my latest repo I have created, isn't it? Repo for GitHub workshop. If we click on this thing, it will open our repository. There is only one branch. We will talk about branches maybe if time permits. Otherwise, we have only one branch. We want to add a file to it. You see here, add a file. The green box. Upload a file also. You can upload a file also. So either you can create or upload. That's how you add files to it. So I'm going to create a new one. First thing, give a name. New file 1 on GitHub. What kind of file we want it to be? Let's say I want it to be a .md file. I given a name, press enter. Give some code to here. So I'm writing some MD code here. This is a new file. Line 1 of new file on GitHub. We are practicing markdown syntax for GitHub file. All right? You've written markdown. If you click on preview, this is how it looks like HTML code. You've written the markdown. This is the preview. All right. Now this thing is important. This is a repository, right? We are telling GitHub is a remote repository. It provides you version control. That's how you commit it. So you preview it. You commit this new file to the repository, just like your local stuff. But when you commit something, you need to provide a message, right? So we are simply giving a message. Commit a new file, give a message. So we are committing, adding a new file to my existing repo. Then you're saying commit directly to branch. So your add and commit will happen at a time on the remote. So commit new file. Saving everything, done. You see the new file? This is the commit message we have given. Adding a new file. And when did this happen? Just now. When did the other two things happen? When we created it. How many total commits are there in this repo? 2 commits. When we first created the repository and when we added a new commit. This is the latest commit ID. You will normally see 7 digits here. 3, 3, 3. These 7 digits are the first 7 digits of commit ID. You see this thing here? When we do a git log, you're getting commit IDs. These things. Out of this full big thing, the initial 7 things are usually listed everywhere. And that's what you are seeing here. All right, that's a commit. You can see the entire list of commits by clicking on the commits. Click on commits. These are the commits that happen. You can see the big number here. You see? This is what happened in that commit. This is a new file that is added, showing 1 changed file with 3 additions, 0 deletions. We'll come to this thing at a late point of time. Right now, let's focus on the big picture. So we have added a file and then we committed that file. So we did these things on remote repository, isn't it? So what are the tasks we finished? We created a free account on GitHub. Let me take this off. Ratio. So we created a free account on GitHub. Then we created an empty repository. We did not actually created an empty repository. We created a repository with 2 files, the .gitignore file and the default readme file. Now, if you did not select it, that would be an empty file, empty repository. Then we added a file. We added a new file. Then we committed that file to the remote repository itself. All right. Let's look at our next step, clone. This is one of our commands that we talked earlier. So let's go back to our list of commands. We are still with the old set of commands, guys. Here, I don't think I have listed it here. We're not doing any push at git clone. When you say git clone, you're basically saying on your local repository to bring something that exists remotely. So here, come back to our list. We have a remote repository here. What's the name of the repository we have created? This thing. So let me put that repository here. This is the name of the repository. What's the URL of the repository? There are 2 ways to take the URL of the repository. One is from the URL, or a more accurate way would be from your HTTPS. Now, if you observe this thing, it's basically, it ends with a .git. That's how all the repositories will end. All right. So .git. So this is the URL of my repository. And I want to bring this repository from my remote, which is on GitHub, to local, which is my laptop. Right? So where do I execute the command? Here or here? That's a nice question, right? This is your client server model. Who does the thing? Client or server? I'm breaking. Okay, just give me a moment. I want to clone the repository that I just now created, which is available on remote. I want to bring it to my laptop. Now, where do I do it? I can do it locally or I can do it remotely. Both are possibilities. And so you can push from here or you can pull from here. Both possibilities are there, but in case of current Git's common practices, it's not possible to push from here to here. Instead, we basically pull from here, bring everything here. And our command is going to be one of the 2 commands, either git pull or git clone. We will see the difference in a moment. Does git compile the code when we add commit? No. Git does not know anything about Java. Git does not know any programming language, so it does not compile. Git only tracks the changes. If you want to compile the code, you have to run the Java compiler, Java C. Isn't it? So that should be done on a remote system somewhere. So Git only is tracking the change. So here, two commands relevant to what we are trying to do here. We want to bring a repo from remote to local. In this specific case, we are doing a cloning. So I'm going to run a git clone command here. Before we go into the command, let's try to understand the command. So this is the URL. All that I have to do is tell Git to clone it. Git clone the URL. Simple, right? Now, for the clone to happen successfully, this repository has to be accessible. Accessible means if it is public, everybody can access it. If it is private, you have to tell Git about the username password to access it. Isn't it? That's a common thing to understand, right? We are trying to access something. If it is private, we need to provide a username password. If it is public, anybody can access it. Right now, what kind of repository this is? Public or private? When we created it, we gave that data. This is public at this point of time. If you are not sure what it is, you can simply look at the URL, go to GitHub. All right. You can see this thing. That is public. There's another question here from Anil. Can we use git pull instead of git clone? No, we cannot use git pull for the first time. It has to be git clone. Git pull requires that you already have that repository local. So come back here, git clone we are trying to do. What's the command? Git clone and the URL. I'm going to execute this thing. Now, when you execute it, where does this repository come to local? So here, these are the three files which are part of this repository. When you are cloning, what essentially means is you are bringing these three files to your local laptop, right? In other words, you are downloading these three things. When you download, you need to give a location, isn't it? So when you run this command, git clone, it basically brings all the files to the current directory. Which means you have to move to the proper directory and then run the git clone. So let's do that. So here, what's our current directory? pwd temp remove my new git repo. We don't want our repo inside this directory. This itself is a repository. If you go back here, understanding these basic things are really important, guys. So see this thing? This thing is one of the repositories that we are working so far. We did not push it to the remote yet. We might do it in a moment. Right now, we have created a new repository on the remote system. This is the name of the new repository. We want to bring this repository to our local system. So here, take it off. So here, we want to have a directory with the name of the repository, and inside that directory, all the three files that we have created on github.com should exist, right? So I'm going to reach this location. CD dot dot is the parent. Or if you're not sure about CD dot dot, forget it. CD slash D. Where do we want to go? Temp remove. This is our current directory. List it. This is folder 1, folder 2, my new Git repo. This one. The dot file is not visible because you simply did a ls. If you want to see the dot file also, you do a dot -a, all files, that is also visible. All right. These are basic Linux commands. Don't worry. Only 5 commands you will use in Git. We are already using all those 5. So ls-a probably is a better option for all of you because you have some hidden files here also. So here, ls-a, I am currently in temp remove. This is where I want to clone my remote repository. So copy paste that command. So git clone the URL. I'm copying it and pasting it onto the git bash terminal. See this thing? Enter. Cloning into this directory. This is the name of the repository. So it created a directory. What exactly it's doing on the remote? It basically looked at 7 objects. It's counting those objects, compressing those objects so that it can download them quickly. Everything downloaded. It received all these objects. It made a local directory structure. Don't worry about the meaning of each one of them. As long as you have no errors, that's fine. So what happened just now is we have cloned a remote repository to local. Let's see that on our directory structure. You see the new file, new directory here. This is your repository. Any questions here? This is the first time that's happening. You're cloning a repository. Take a moment and try to understand what we just did. We created something on the remote and then we cloned it. Now let's go inside this thing. Does it look like a Git repository? The .git file, is it familiar? The .git file, you see this thing? So even on github.com, all that it is doing is creating a repository, just like we did it locally, isn't it? That's all it does. Inside this Git, you have the exact same directory structure that we have seen earlier. But this is for the newly created repository. Now, can we change something in this? Can we change something in this? That's our next steps of our cycle. We're doing an end-to-end cycle. So here we clone the repository. Now everything is local, isn't it? You got your friend's code. Your friend has uploaded his code or he created a repository on github.com and you cloned it. Now everything is on your local laptop. Now you want to add your own files, which is our next step. Add some files. Track them, zip them, and finally push it to remote so that your friend can take them. Shall we go ahead and finish these things quickly? I know that you are feeling hungry. I'll try to finish it quickly. All right. Clone is not like a 4-click. Only way to run commands. That's a good question, Anusha. We will tackle that towards the end. To answer your question, Anusha, these commands that we are doing, right? there are GUI-based tools also to do these commands. There is a tool, I'll give you that tool towards the end. But the reason I am not giving you the tool is you won't understand the concept. Once you understand the concept, any tool will do the same thing. And you will be able to do even without a tool also. So I'll come to tool in a moment, Anusha. You can do using a click also. So let's go ahead and finish our step 6 and step 7 in the new repository. So this is our new repository. I'm going to add a file. But before that, let's do a status of this. We're working on a new repository now. ls, this is our new repository. Double click it, it gets selected. cd, right click, paste, enter. You're in the repository. And when you are in the repository, you can always run git status. What does it say? You are on master branch. Your branch is up to date with origin master. This is another new word. Origin is a word representing the remote repository. It's basically saying this whole thing originated from github.com. Remember this word origin. So here on the image that we were dealing with, this is the origin. github.com is always the origin. That's a very common word used. So let's take that word. Origin means repo on github.com. It basically represents that your local repository originated on github.com. Then it says there is nothing to commit. Working tree is clean. Working tree is again the same architecture, the 3 pillars that we always talk about, isn't it? This is a working tree. So every Git repository will have these 3 trees, logical trees. So now let's go ahead and add some files to this tree. Start indexing them. Finally, commit to them so that we can save them. But we are doing it everything in a new repository. So I'm going to add a new file. Click new, just add a new file. So new file 2 added on local Anil. You can add it later for yourself. So I've added a file. I'm also changing the readme file also. All right. So we were making multiple changes here. Add a new file, change an existing file. I can edit it using any of the editors. Using Notepad also is fine. I'm just editing it. So I'm going to add a new line. So here, this is a .md file. So added, I'm going to add a couple of lines here. 3 lines will represent a horizontal line, and this is a bullet point. Changing this line, added this new line locally. All right. Save it, close it. Remember, the file name did not change. Let's do a status, git status. It should tell us about 2 things. One is, was there is a new file added, and then there is an old file that I changed. You see, there is an untracked file, then there is a changed file. So we need to commit this, and then we need to track this. So let's first add this file to our tracking, and then we will commit everything at the end. So what's the command for adding? Git add the file name. Here there is a slight modification. I am changing an additional one. If let's say there are multiple files, instead of one file, Let's say there are multiple files. Let's add another file. I'm going a little fast here. Stop me if I'm going too fast or ask the question. So instead of file 2, I'm saying file 3 also added. .txt. So 2 files, git, status, multiple files. Now, if there are multiple files, I can add each file every time, multiple commands, or let's say there are 100 files. I don't want to run 100 files. I'm a Java developer. I can write a program for anything, isn't it? So just say star, everything gets added. So everything that is in untracked list gets added to staging in a single go. Now let's do a git status. What are we seeing? So something is modified, then there are 2 new files. Everything has to be committed. We did not store them at. Shall we go ahead and commit them? So git status again. Always learn this habit. Git status, status, status. Make sure you have everything on your mind and it's visible. So git commit, message, new files added locally, and readme file changed. Done. See this thing? 3 changes were done. There are 3 insertions, 1 deletion, which means in the readme file, I think I changed something. Any change is a deletion or addition. If it is a complete new thing, it's a new insertion. So don't worry too much about these things. You get more clarity as you go in, but you understand the overall, summary of what is happening. So we have made 3 changes. Those 3 changes are coming here. Total 3 files changed. So we did a commit. All right. After commit, what's your normal command? Git log. You should see the latest commit somewhere. Initial added, new file, new files added. This is our latest commit. All right. You can see it from the masses. So let's go back to our list of commands. What are we trying to do? 6th and 7th, this thing. So perfect. So we are done with 6. We've added some files. Then we did git add. We did the git commit. Our last and final thing, git push. So you want to push your beautiful code to the remote one. Now, before you do that, there are a couple of things that you have to do. Oops. You have to tell about yourself. User name and user email. One thing. Second thing, if you are pushing the code, and if it is not your code, it's remote, right? You need to give some kind of username, password. Yes or no? So let's set up these 2 things. But before that, let's try it first. Let's see what is the error you would get if you don't do anything. Because you're going to get the same error when you try it also. So I'm saying git status, everything in, nothing to commit now. All right. Look at this thing. Your branch is ahead. Sorry about that. You're ahead of master. What does that mean? Each message that you see on the screen is important. What does ahead means? Your changes are new. That's what ahead means. Ahead of master means the remote guy. Means you are doing something which is ahead of master by how many commits? 1 commit. Means you have 1 extra commit compared to master. That's the whole reason we are pushing our code, right? New code. We have made 1 commit. If we make another commit, you will see you are ahead by 2 commits. Shall we do that quickly? Let's do that quickly. So I'm going to add another file. For delete.txt. Same process again. What are the next 2 commands? 3 commands. Git status to see what is happening. So there is one untracked file. Add it. Git add everything. All right. Then git status again. So everything should be ready for commit. So changes to be committed. Git commit with a message. New file added. One file changed. All right. Now, if you see git status, how many commits you are ahead? 3 commits. So your local repo is ahead of remote by 2 commits. Now let's try to push it. Push command is similar to the clone command. This thing. That's a very basic command. But we have cloned this repository, right? Initially, isn't it? And when we cloned it, we gave this URL. When we give this URL, Git stores that URL somewhere. It knows the remote. So if you say git remote, or let's say verbose, it is telling you the origins URL. This is your next command. Git remote -v. You are asking, what is my remote? Let's look at that thing. That's our next command. What if you don't know all these commands? Is there a place where you can see all these commands? Git remote. I'm only talking about some of these commands, right? You can just do a git and you will see everything. The reason I am not talking about, we're not talking about all the commands is you don't need them. We're talking only about some of them. We know clone now, we know init now, we know add now, and we know status, we know commit. Some of the important things we know. But if you want the entire list, it's already there. So don't worry about everything. So git remote -v. So you're basically saying, if you want to push it, you are pushing to this repo. So let's try to push it. Git push. You can give the whole thing. Copy paste. That'll work. Let me make the command better. Git push this. All right. Copy. Paste. Space. There is a space. Enter. Let's see if it works or not. It worked. You know why? I think I have that thing already stored. The username password is stored in my laptop. It actually works. Compressing objects, writing objects, total remote, resolving deltas, and it went ahead from local to remote. So it actually went to remote without asking me for password. The reason is I have the password already stored. Let's go to remote once. Refresh this page. You should see all the files here. You see all the files. There are 4 commits. We have added 2 additional commits, but this will not happen for you because I did not give any username password anywhere. It's not that you can push to any public repository, right? So I'll have to remove the username password. Let me try another way. These are window commands, right? Windows commands. So ls will not work on Windows. Alternate command for ls is dir. Username details are, yeah, they're not stored in host file. And then they are the difference between fetch and push. No, fetch and pull. So there is a difference. Those are related. We will talk about it. Maybe we are running short of time. Just give me. Let me fix this. Usually give you username password. Let me try this thing. Git push. We are in that directory. Git push. You can see that, right? Git push. What's our? I want to show you the error you would get if you don't give the username password. So that's your git command. See if we can show properties. Font. So yeah, I'm trying to run it on a different terminal. Let's see what happens. Enter. Oh, even here it's picking it up. My username password already stored. So if you try with a different username password, or if you try on a different repo, you usually, let me try on a public repo, which is not mine. I'll clone another repo, public repo, and try to push it. All right. Git Java repos on GitHub, just like we did just now. So trending repos. I'm going to clone another one. This is a public repo, but not my repo. This is somebody else, Iluwater or somebody. I don't have his username password. All right. But because it's a public one, I can clone it. Clone it. So I'm going to clone it. What's my current working directory? cd dot dot. So I'm going to clone it here. Same location. So when I clone it, a new directory gets created here. So git clone. Best. So it's cloning design patterns, everything coming down. Looks like it's a big one. We are running beyond time, guys. We'll close it in a moment. Just give me. There is another session? No, I'm not permitted to take another session, but there will be another batch which will restart everything from the beginning. So in that batch, maybe we will have a more structured way to do it. So this is clone. Let's see the clone. You got the design patterns here. This is a newly cloned repository. Oh, this guy is working a lot. See this thing? All these things are there. Look at the Gitignore file. This is the Gitignore file that he is using. This is the real-time Gitignore file. All right. So let's go back and try to add a file to this repo and try to push it. So cd Java patterns. I'm going to create a file here in this. Create new file, text file, file created by Anil. So git status. This is an untracked file. All right. Git add the file name. Git status again. Sorry. Git status. So this needs to be committed. So git commit -m local file added. Now the question is, can we push it? Look at the remotes. The remote is owned by another person, that guy. Can we push it? Git push to a different somebody else directory. We don't have his username password. Let's see what happens. What happened? First line is the most important line. Permission to something is denied to my user. My system knows about my current username password, but what it does not have permission is to move it to other thing. Now to reduce this error, or if this is your own repository, we will be giving a username password using a mechanism. So I don't think I have time here. Let me skip this thing. So that's your git push we have done. Let me give you a tool to do this whole thing using GUI. It's called GitHub Desktop. The GUI tool for doing everything on Git. So this is a GitHub Desktop. You can download, it's free of cost, and install it. And when you download and install it, you would get something like this. And save. You see this thing? This icon? GitHub Desktop. All right. If you open this, double click, you get a nice interface wherein you can connect to your remote repository. You can do everything here. So let me try to do something. So click here. You can create a new repository locally. You can clone a repository from GitHub. So from GitHub, you simply sign in, continue with your browser. So I'm going to sign into my organization. This is not correct. You should not get this thing. Let me try. There's another username. Need to get the username and password for that. There are multiple usernames, so I'm just picking one of them. No, it's not here. To improve your security, so we need to change it. Let me continue with browser again. I'm trying to log into GitHub using my current ID. Where is it? This is not correct. I will log off. This is a different account. I'll log in again with the one that we are using. Let's go to the repositories. The repositories. Click on repository. This is the repository we just now created, right? Let's get back to GitHub. Continue with the browser. It has to authenticate. Not working. Let me cancel it and try it again. Cancel it. Try the GitHub again. File, clone repo from GitHub, sign in. Now it's authorizing to my GitHub account. You see this account name here? This should be correct. If you have multiple accounts, make sure you are connected to the correct account. All right. So this thing, authorize. The site is trying to open GitHub Desktop exe. Okay. Authorized. So now I can do everything that I've been doing so far using click. Have you put your logo also in this repo? No, I did not put Ajay my logo. So come back here. This is one of the repositories. I'm trying to clone a repository. Can create a clone repository. We are on GitHub. These are the various repositories from my account, guys. All right. See this on the GitHub. Now everything is a GUI mode. So we are on GitHub. Shall we clone our repository again? Just do one thing. This is the repository. We will clone it to a different location, but using desktop. So filter using URL, let's say. Local path. It's asking where do you want on local system for this clone to happen. So I'm going to change the location. Choose a different location on this thing. Temp remove. I'm going to create a new folder. Folder for GitHub Desktop. I'm going a little fast, slow. Sorry about that. So under this, select it. Now I'm going to clone it. It's cloning a repository from remote to local, but this time using the GUI thing. So you can see it here. Your current repository is repo for DS, whatever it is. There are no changes. You see, there are no changes. There is no history, nothing. Let's make a change quickly and see if it gets visible here. So temp folder for this thing. Let's add a file. Add a new file. You see this thing? Added a new file. The change is here. Now you can push it really fast from here. So you can do a commit here. Commit to master. You're not executing the add and commit commands anymore. You are doing everything from the GUI. Then here you can see push to origin. So you click push to origin. It moves to origin. It's moving here. Done. Let's go back to our remote repository. See if we got the latest file. Refresh this page. You got the latest file. This is the one that's added. So everything that we have learned so far, we just did using GitHub Desktop. Of course, we can go into details, each one of those things, but time does not permit. Maybe another session or probably a repeat of the same session with more time on each session will do. All right. So for now, I would like to close this batch. So we had finished some important things because of the time constraint. So we understood what Git is. Let me summarize what we did quickly, 5 minutes. Just last 5 minutes, huh? So we learned what is Git is. We learned Git architecture. We learned Git basic commands are about 7 or 6 or 7 commands. Then we learned about Git remote. What's a remote? Then we learned about github.com related important stuff. We learned about creating local and pushing your code to remote. Then we looked at Git GUI based client. What's the client name? GitHub Desktop. These are the key learnings that you have done during the last 2 sessions. All right. Now, if you do not have any questions, thank you very much, guys. Summary wise, this session, this batch is done for now. I'm not allowed to extend these sessions anymore, but I will announce another GitHub free batch probably in the mid of January. All right. The content of that GitHub will be more structured. Even if you have attended this, I'm sure you can learn a lot of things. Like some of you are suggesting Git branching. That's another important thing we haven't got time to discuss. Then there is a pull request, PRs they are called. That's a very important thing. Ideally, if you have another session, I would have covered those things. But we will have another batch mid-January. Please look out for my batch. You will get it in all channels and everything. So there you will have more structured, more in-depth, probably added contents. Let me answer some of these questions here. What's the difference between fetch and push? Fetch and push are not related. Fetch is to bring something from remote to local. Push is the opposite. Is there any other session? No, not for this batch, but there will be a new batch that will be announced mid-January. That will be more structured, Ajad. So please make sure you attend that also. You will definitely get more information and learnings. Have you put logo? No, I did not put any logo anywhere. And then what's the subject? What other subjects you're taking? I'm taking Linux, AWS, and DevOps. All focused towards developers. I'm a cloud architect, but I work mostly with developers. So the course structure here in DURGASOFT is tuned towards developers mostly. So I'll be taking Linux, AWS, and DevOps, and some of these workshops, GitHub, Maven, sometimes AWS, or we can have a Azure thing. Anything pretty much except programming. Do you have a regular badge on GitHub? No, the GitHub is part of our Linux, AWS, DevOps course, Alok. That is I think there is an add-on batch starting tomorrow, Alok, that you can join, but that will be a very long one. Check it out. Regarding branch creation, pull request, yes, Amar, I will explain about branch creation, pull request. Maybe in our next batch. I could not add that thing for this batch. We have already extended beyond what is permitted, 2 sessions. So Anadin Mirja, just go to quick pull fetch and how to resolve conflict. That's a little more complicated than quick one. Anadin, I'm really sorry. Maybe I will add a video to YouTube under DURGASOFT channel. You can have a notes, Anusha. I will upload these notes by today evening or tomorrow. Everything that we have seen here on the screen, I will add most of the same content and images so that it's familiar. I've cloned the main branch to local and made changes to code, and now we want to create a branch. Branching thing we haven't talked about, Amar. We will talk about it when we get time. Do you have to take a regular batch or not yet? It's part of Linux, AWS. Please take. Maybe I will add GitHub. Do you want a regular batch on GitHub? No, right? We're actually covering everything on a free workshop. Don't pay money when you can get it free. But see, look, we will see. Thanks for that suggestion. Amar, you can show quickly. I'll do it probably next session. Amar, Git, it is only 2 days content. This is just demo. Complete content will be more. Yes, Nitesh Pathak, yes, complete content will be more. I have covered about 50%. I would like to cover the remaining 50 also, especially for developers. There are things like branching. Then there are things like pull requests. There is Git stashing, merge conflicts resolution. Then there is a Git flow. It's how the real world project, the branching strategy is usually done. That's the real world, real time thing. That will be the remaining 50%. Maybe we'll have an advanced session somewhere. That's Nitish. For Naga, can you please share your today's session? Yeah, Naga, it will be uploaded by today evening, all the recording. How to resolve conflict. Anodine conflict resolution happens during the PR merge. So when we talk PR merge, we will talk about results. So that'll be all for now, guys. Those who waited for a very long time, thank you very much for being very patient, for listening. If you still have any questions, I'll still be available online for a couple of minutes, for about 10 minutes. You can post it. Otherwise, you're good to go. Offline, guys, thank you very much. Thanks for your patience, guys. It's really nice. Linux recording, I'll chip in, then follow up chestam. Thanks so much. Yeah. Any other questions, guys, online? Thank you very much, all of you. For being very patient. I know it's beyond what you promised me time, but thanks so much. So if you don't have any questions, you can drop off for today. Maybe there'll be a next batch sometime in the mid of January. We'll meet again. Please do join, even if you understood everything. The next batch will have more information. It'll be more structured. The notes will be ready by then. It'll be updated notes. So I'm sure you will get more information then. All right. All right, guys. So thank you very much. You can disperse, relax for the day, and don't forget, evening there is a FIFA World Cup happening. France versus Argentina. It's expected to be really high octane game. Watch it. Naga, when will you start AWS Azure DevOps? That's it. Azure developer. Oh, okay. Azure is not started, Naga. Maybe I'll plan something in end of January. You're looking only for Azure developer or both of them together? AWS is currently going on as part of Linux AWS thing. But yeah, Azure developer also, there is a plan to start. That would come mid of or end of January. There'll be 2 separate sessions, I think. Yeah. Just keep a watch on it. You will get messages. Thank you very much. Thanks, Naga. Nice talking to you. Any contact? I'm available through DURGASOFT. You can always reach out to somebody in DURGASOFT. They will pass the message to me. Ajad, if you want to reach out to me separately, I don't think I'll find out some way, Ajit. I think if you want to reach out to me, maybe I'll set up a Twitter handle or something so that people can talk to me. That's really important. Yeah, Ajit, thanks you very much. That's I'll set up a Twitter handle and post it to all DurgaSoft students. Amar is asking 19th December 7 p.m. new batch. Yes, Amar, that's an add-on batch starting tomorrow evening. Linux, AWS, and DevOps thing. 7 p.m. it's starting tomorrow. After a 10 days period, it will be moved to 6 p.m. So if you're okay with that, you can join me tomorrow at 7 p.m. Amar. Nagabi, what topics you will be covering on AWS developer? AWS developer, let me show it to you quickly. It's already available on the internet, I think, but if you're seeing my screen, I think I have it somewhere. Let me just. Where do you have it? This is the course content. Naga, this is the course content. I'm not sure how I can pass it to you. Can I post it here? To this chart? Let me try it. Yeah, that's the course content for the Linux DevOps V1. I hope you got it, Naga. You will have everything over there. Ajad, Amar, Ajad, what exactly you're looking for? Let's talk, quick talk. Will not take more time. Ajad, yeah, I could not hear you so far. Can you talk?
Yeah,
Yeah, go ahead, Ajad.
Yeah, actually, I wanted to know about Linux and AWS things. So currently, I'm working with the programming skill with the Java backend developer.
Okay.
So I wanted to switch with like which types of you told like not a coding part and remaining part. So where I need to shift how to proceed.
You are planning to move from development to support?
Not support, but
okay. You want to learn more about the cloud and DevOps part of Java development, is it? You want to get better with that area?
Yeah. And one more thing is there to talk to you. Currently, something is happening, so I could not talk here. If I can talk, then I can tell you.
Okay, is there a way to talk one-on-one here? Okay, let me see. But okay, so to answer your first question, that you wanted to learn, developer-related things of cloud and DevOps, this course pretty much targets the exact same thing. Linux, AWS developers. For developers, we are only targeting. So if you see, we're targeting Linux commands for Java developers, especially full stack, and then AWS related things of Java developers, especially if you see these things. All these things, even though a lot of support people learn these things, we have covered the basics of cloud, and then we moved into areas used by developers. For example, Elastic Beanstalk, the same way X-ray for auditing and everything. Then, what is called API gateway, which is
Yes.
extensively used by developers, because now everything that REST API that you create are APIs. They are
Yes,
exposed
yes.
outside through a gateway. Then the serverless Lambda functions, that part. So what we did is we have fine-tuned the course towards developers. So I think this would work. This would suit better for your requirement. Even the DevOps thing, which is part of this course, the DevOps thing, we are focusing more on developer aspects only, not the operations aspect.
Definitely, I will join. Definitely, I will
So
join.
the reason being, I got this request specifically from Nagoor sir and Durga sir that most of our students, because they are developers, if we can customize our courses towards developers, it will help many of our students, was the discussion. So I have converted most of this discussion into towards developer oriented only. So these are not for support people. So we don't focus too much on monitoring. We don't focus too much on alerts, on-call support. No, we don't talk about those things too much. We talk more about tracing, debugging, this kind of thing.
Mm-hmm.
So these are our more focused towards development. That's your answer to your first question. About the second question that you wanted to talk about, maybe we can set up a call tomorrow or sometime whenever you are free. We can talk.
Today evening, is it possible? Oh, match is there.
Today, no, not about match, but I have some other commitments.
Or
I'll have to move
you
on.
can pass some numbers so I can talk to you directly in phone.
Mm-hmm.
It will take 10 15 minutes, not taking more time.
Can we do it tomorrow?
Tomorrow
I have a session at 7 o'clock. After the session is done, we can continue this call. Google Meet or some other thing. That I'll give you that call and we'll talk. I'll give you another link. We will talk, only on that call tomorrow evening.
7 morning or evening?
Evening. After 7 to 8 is the class going on.
Okay.
If you can join that call, and around that's a free class tomorrow starting. So
which class?
The same batch, Linux, AWS, DevOps.
Okay.
So the same batch, 7 to 8 batch, not the 6 to 7 batch.
Okay.
7 to 8 batch you can join, and towards the end, I'll give you a link. You can join that link, and we will talk.
Related to placement, anything you are giving suggestion, like anything related to company or placement?
I can actually give a suggestion. We are planning on having a session on that also.
Mm-hmm. No, actually,
What's the question?
Currently I'm suffering something, so that's why I wanted to talk to you. That's why.
Definitely. We will talk. We'll talk. Not a problem. We'll talk.
If today is it possible? It will be because tomorrow I have office and I need to perform something. So that's why
we will talk tomorrow. Ajad, if that's okay.
Okay.
I'm running late for something.
Yes,
I'm extremely sorry.
Thank you, sir.
I'm extremely sorry. We will talk tomorrow evening. All right, not a problem.
Yes. Thank you.
Yeah. Anything else, Ajad?
No. Thank you, sir. Very grateful session today.
Thank you very much. Ravi, you're saying something. How about branches? Branches.
Yes, Anil, can I speak?
Yeah, Ravi. Yeah.
Yeah, Anil. So Anil, currently I'm working as an automation tester with 8 years of experience. So where I know that how to work with branches and check out between the branches, and okay. But the thing is that exactly how does it work? I'm not aware. So how to create the branch, how to check out between the different branches?
No, that's a pretty simple one. Let me give you, a big picture. So normally, when you're working on the master, that's only one branch. You create a branch by doing a git checkout. So git checkout -b branch name. What happens is from that commit onwards, or until that commit, a copy is made. A copy is made, kind of. Then any change that you do, And any commit that you do will be added to only that new branch because you checked out.
Yes.
So your working directory has the code related to new branch.
Mhm.
Then you go ahead and you, let's say you add a file, then you run a git add and then you run a git commit. So the new commit that happened is on the branch only. It did not go to the master.
Yes.
Let's say after few commits, you are happy with your code. Then either you can push this entire branch to the GitHub remotely, one way, so that others can review your code, or you can merge your branch into your local master only
Mhm.
using git merge. Then what you do is you first jump to the master. You basically say git checkout master. You don't give -b. -b is when you're creating a new branch.
Mhm.
If you don't give -b, you are moving to an existing branch. So when you say git checkout master, you go to the master branch and then you
Anil,
do a git
sorry to
merge.
interrupt. Anil, sorry to interrupt. See, I'm aware of these things. My question is, I know that when we commit something, then we have to merge it to the main branch. So I'm aware that. My question is how to create these branches, okay, in the main. So that is my question, Anil.
Git checkout -b branch.
That's it.
That's it.
So in the room remote. So from the remote, can we create the branches, and from there we can fetch the branches into the local. Then we can move it.
Yeah, you can create it
So
here. You see on this thing, you have branches, right? Master branch here. You
okay.
click on it. Now view all branches. You create a new branch here. Find or create a new branch. Let's say new branch. I'm creating a
Okay.
new branch. Create a branch. A branch is created. So I have 2 branches now. Currently, I am
Oh,
a new branch, or I can shift to
Mhm.
master branch. Now, when I
Yes,
clone
yes,
it,
yes. This is something I
everything
want.
comes
Yeah.
down. Yeah.
So when we create a new branch from the master branch, it means that all the code that we already have in master branch flows to the what do we say, other
Right.
branch. Am I right?
Other branch also. Yes.
Okay.
And any
Okay.
commit that you do here will be available only on the new branch until you merge it with another branch.
Mhm. Okay, I got it. Yeah. Sorry. Thank you so much
Yes,
for that. Carry on with
that's
your work.
that's okay, Ravi. Thank you very much. That's all, guys.
Yeah, yes, tomorrow session link I don't have. How to get that one session?
Tomorrow session link. Hold on. I don't think they have a link. 19 batch. Hold on. Java. Linux, DevOps, data. December 14th, 7. Is this thing? I'm not sure. I'm not sure if they created it. Won't they have it on DURGASOFT website? Should be on the website. Down there's a okay. Looks like Abhishek found it. Down. Oops, this website is too complex for me. Full stack Java, core Java. So yeah, this is the one. Yeah, this is the one you can see.
Yes, yes.
Huh? It's available on durgasoft.com. Just search for 19th December batch. You will be able to register it. Huh?
This timing, it is showing 8
This is 7 to 8.
AM. It is showing.
No, that's wrong. Oh, this is somebody else. Sorry. This is Mr. Mahas. This thing. I think there is another batch starting. This is mine. Yeah, DevOps with AWS. This thing. This is
Okay.
Anil. You have a link here. This is at 7 p.m.
Okay.
All right.
This is new batch or what?
This is an add-on batch. We have an existing batch running for last week or so. So this
Okay.
batch will be moved to 6 p.m. after 10 days.
Okay. Okay. Got it.
Yeah.
Thank you.
Thank you. Thanks very much.
Hello.
Who are your favorite? Alok. My favorite.
Hello.
I'm going with Messi for now. Yeah.
Yeah, Anil. Will you cover Glue and EMR in AWS developer?
No. EMR, maybe the basic thing, but not really. Glue, I'm planning on adding, but not too much the coding part. Basic outline mostly.
Okay. Okay, and one more query. Glue and Glue Studio is both are same. Like Glue Studio, we can write the code in Glue, right?
Right. That's correct. You got it. Mm.
Okay, and how many days this batch has started? Or 10 days? Or
Git one?
No.
Is this
6
Abhishek?
PM. AWS developer. AWS.
No, your name. You're Alok or Abhishek?
Naga.
Yeah, Naga. AWS DevOps started about 10 days before, I think. But there is an add-on batch starting tomorrow evening, 7 p.m. So after, that will go on for a week or 10 days, and we will merge it with 6 p.m. batch. So 7 p.m. it's starting. 6 p.m. will continue.
Okay.
7 p.m. will be merged into 6 p.m. in 10 days. But 7 p.m. is just starting. So you can actually start tomorrow if you are planning on doing that. Amar is asking, are you planning to start a new batch in morning hours? Yes, Amar. New batch is actually my preference. I don't want to do it evening. I could not find time. The new batch will start in Feb, Amar. All the batches, my batches will be in the morning only. Naga, sorry, I missed you halfway. Is there any other questions you want to ask?
Yeah. Okay. Is there any new batch will come in future? Like after? Actually, it has 10 days has gone, right? So that's why.
No, but the new batch will cover all the things from the beginning, and then only it will be merged. So tomorrow 7 o'clock is a new batch.
Okay. 7 a.m.
7 p.m.
Okay. 7
p.m.
Okay. And Glue is also in a coming batches will cover or this batch?
This batch, I'm not really sure, Naga. If you want me to give a specific Glue session, I can take a half-an-hour session for you. Not a problem.
Okay, great.
That's fine. That's not a problem. Like we can always, spend half an hour or 1 hour to, to give you some clarity into your specific area. That's never a problem.
Okay. And for writing the code, we can use Python, right? Python.
Python can be written, not a problem. But yeah, I mean, that's easy if you are starting it out.
No. What is the program language we can use in AWS developer, right?
You can
Python
use anything depending on the CDK or SDK you are using. Java, Python, .NET, anything. Doesn't really matter. AWS provides infrastructure only and specific services. Like, for example, you are doing a Lambda function. You can write Lambda function in any programming language. The runtime environment, you choose the corresponding one.
Okay. You can you will give the Python or Java or .NET for program language. You can explain.
Mostly Java. And we are not really going into the Java code. I'll probably pick some basic Java code, hello world, I think, and we will show how this is done in AWS. So this is more from a cloud perspective rather than a developer perspective.
But I have experience in Python, so
You
is it
can
okay
do a
for?
Python also. That's fine. Just the code, right? I
Yes,
have
yes.
a lot of Python programs. I can pick up one such Python program and show it to you how a Lambda function is run. Not a big deal.
Okay. But EMR we can creating cluster, right? EMR is also important, or
It is
it
important, but
mandatory or
EMR,
not?
map reduce, all those things are, unless you are specifically doing that, this course covers the basic, overall feature set of AWS. EMR,
Okay.
if you are doing into Hadoop and other stuff, EMR I might want, but it's not really specific to developer as such, unless you are doing, the map reduce functions or those things. EMR, I don't think will add much value to general developer. What we try to focus here is, nothing specific to any developer, but common to all developers. Like beanstalk. Beanstalk is common for all developers. Lambda is common for all developers. API gateway common for all developers.
Okay.
That
Kinesis and RDS. Okay.
RDS, yeah, we will cover RDS. It's a common
Kinesis.
required by all.
Kinesis.
Kinesis is a specific stream management thing. Not every application will use Kinesis. So I don't think it adds any value, because we need to reduce the number of services we touch upon rather than increase it. It will only confuse you. So for example,
Yes.
Kinesis, if a developer is asked, do you know Kinesis? And that person says, no, I don't know Kinesis. It's a perfectly valid answer. Because unless somebody is using Kinesis service, they don't have to know it. Whereas API gateway, if the developer says, I don't know what API gateway is, then that's a mistake. Every developer should know what an API gateway is. Because API gateway is a very common service used by all developers. So our target here is to focus on those services which are mandatory for every developer, which will be asked in your interviews, which add value to getting you a job. That's the focus here.
Yeah, whatever. Okay, you are explaining like teaching Linux plus AWS plus DevOps. This is enough for we are getting an we are switching to another job like AWS developer, right?
Yes.
Okay, great.
Yes.
And what about RDS and Redshift is also
RDS will be added. RDS we will talk. RDS, you need to know some databases, at least Oracle, MySQL, and one cloud native database like Aurora. Redshift is when you are doing data warehousing, when you have large amounts of data, like petabytes of data, and you are doing EMRs, map reduce, those things, the Redshift becomes more relevant. But otherwise, RDS is a common thing that every developer should know. Redshift is more a value addition. Okay. If you are working on data warehousing applications, then only you need to know Redshift. Otherwise, stick to basic RDS, Oracle or MySQL or Postgres, this kind of thing.
Okay. And these topics also will cover solution architect, or we can if
no, these are not for solution architects. These are more from developer associate. A whole thing at DURGASOFT is all developers.
Okay.
Not from a support angle.
Okay. Solution architect. Okay. AWS developer, we can write the certification for AWS developer. This is enough. Okay. For
mostly enough. Even certification, we're not targeting everything. Mostly 90% will cover.
Okay. And what about solution architect? It is admin part plus developer part, or
no, there won't be any developer part. Solution architects are purely support. They're cloud architects.
Okay.
So that curriculum slightly differs. Means there is a overlap of about 60 to 70% at the basic level. The remaining 40% will be different for architects and different for developers.
Okay. Okay, like we can do the infrastructure from root level to.
You can do it. Means there's nothing that you can't do. I wouldn't say it's too much of a difference, but the path you are taking is different. So a solution architect is going to a different path. A developer associate is going towards a different path. When you look at professional certifications.
Yeah, okay. Thanks.
All right.
Thanks. Anil. Thanks. Yeah.
Okay.
got it.
Okay.
Thank you very
Nice
much.
talking
Thank
to
you.
Yeah.
Thank you.
Thank you very much.